Today we are on third day of the presentation on robotics under ATAL AICTE. Yesterday we have covered a different kind of sensors, motors, the system of robots, what is there inside, what is the structure, operational system, and then we have seen some simulations, how to simulate the robot. I have shared the links to website. Today I'm also going to share you the website of one more website, link to one more website wherein we can see how to develop the joints. It is a very useful course. Many of you may like to join that course. It is available online and I will be sharing it in this chat. Today we have lined up series of presentations, one on actual project that we have developed. So that will be handled by not by me but my teammates. And as you have seen, we are working on the robot that we have IDO. We have one more robot, in fact industrial robot that we have. We will go through that robot also. That will be handled in the second session. Third session again will be taken by me. So today we have three different people taking different sessions. So we'll wait for another 5 minutes for others to join and we will start by 10:05. Good morning to all of you. Once again, we are joining today on third day for the session on ATAL IoT FDP on robotics. So here we have lined up three sessions today. One is on a project that has been developed and then we have a session on the industrial robot that we have, and after that lunch session we will have a session on the edo robot that we have worked yesterday. We will continue it further to do some projects. So the first session will be handled by Alka Bhatt. She is working with Electronic Service and Training Center from the last 8 years, and she is working on various projects. So one of her major project is working on Samsung Training School. We have a tie-up with Samsung for training of their products. So she is working with them, and so let's welcome Alka Bhatt.
Good morning, everyone. My name is Alka Bhatt, and I'm working as a Junior Scientific Officer at ESTC. I'm working at the New Delhi branch of ESTC. So, in this session, I'm going to discuss autonomous robot, which is being developed by ESTC. We have already developed it, and it's currently at the exhibition. That trade fair going on in Pragati Maidan. So MSME has a stall over there, and we are being represented over there by MSME. So it's a kind of autonomous robot we are going to discuss with a particular function of killing the germs and viruses. As you know, from the last year, we're all dealing with the COVID. So when the COVID time arose, so we came up with an idea of UV sanitization and a moving vehicle that can do it. So obviously there are the big vehicles in the hospitals. There are big autonomous robots doing that, but we did it on a lower level that can be used in buses, in hospitals, schools, homes, anywhere having a surface, and you want to sanitize that surface. It can go on and keep working on its own. So I'm going to present you the presentation for that, and we'll discuss accordingly. So by this time, I guess you have all learned about what is a robot and what are its types. But still, just to get an overview of the autonomous robots, I'll discuss what is a robot actually. So basically, first the robots were developed just to assist humans. It is the product of a robotics field, but it was programmable just to get a our functions to get them like done very quickly and very easily, because human effort and machine effort, obviously they are different efforts, so to make them quick. So robots were originally built to handle monotonous tasks only, but obviously the time changed, the technology changed, so we came up with the different ideas and we came up with a different level of robots, technical levels of autonomy, ranging from human controlled bots that are like which can do various tasks at full control with full power and with a great efficiency as compared to the humans. So basically, what differs from a robot from a machine? So characteristics of a robot, like it has to get some kind of mechanical construction so that it can do whatever function it has been allotted and whatever function it has been designed to. So it can do that in a very good manner. Robots actually need electrical components that control and power the machinery. Obviously, we all know that we have to give it a power system. Third one, the main thing which actually differs it from the machineries is some kind of computer programming. So we have to go through that. We have to build a program. If you have an autonomous robot, so you have to go with the every aspect: power, time, efficiency, obstacle avoidance. There are various steps which we have to go through when we design and when we so otherwise it will just be like another piece of a simple machinery if you don't give it a particular sense, if you don't give it a particular uh, work to do, particular function to do, and you have to control it in that way so that it can do it autonomously. uh, Next, types of a robot. So let's discuss. There are many types, obviously. So I have majorly categorized into five robots and five types of robots. First one is the pre-programmed robots. They are like actually which you see in a functioning like mechanical or assembly line in automotive functions in automobiles, etc. You'll see a robotic arm doing a particular repetitive function. It has been programmed to do that function. It cannot do any other function whatsoever. So mechanical arm, it's a best example on an automotive assembly line. That is the best example for a pre-programmed robot. Second one is the humanoid robot. So it does the human-like activities like running, jumping, and carrying. Obviously, you have seen that Sophia and Atlas. So from the past various years, we have seen like a major change in the physical structure, in the functions of them. So it's just being increased like every day. Third one is autonomous robots, which we are going to do and discuss for this session. So cleaning bots, you have heard of the Roomba, which is the various like on a large scale, Roomba is being used as a vacuum cleaner service in homes. So autonomous drones, which are particularly they are designed for a particular work and they will do that only. Fourth one is the teleoperated robots, which is like a human controlled like robot, which will do its function on a different area remotely. So best example I could come up with was human controlled submarines used to fix underwater pipe leaks, etc., or any function. If you have and situation going on somewhere where the humans cannot reach easily, where it's beneficial, where it's advantageous to just send a robot and do its function over there, we can go with the teleoperated robots. Drones are the best example to do that. Fifth one is the augmented robots, prosthetic limbs, exoskeletons, etc., which we have seen, which majorly the health industry is using for lifting heavy weights, etc., or giving a function which the humans cannot do easily. So, like robots are being doing the work at a various technical levels. So these are like major hierarchy have designed like for the five types of the robots. So we are going to particularly discuss this autonomous robot because we have developed a autonomous robot, which is a UV sanitizing robot. Okay, so it has a particular function that is killing the germs and virus over the surface and making it a self-controlled sanitizing device. So it has the ability to overcome the obstacles. Obviously, when you're in a home, you're in an office, you are in a bus, anywhere in a metro, so there will be obstacles. So our robot has to be that efficient that it can avoid it and choose its own path. And so, but on the same run, it goes through all the room and obviously sanitizes the whole room. So that is what we came up with, that the thought last year. We did various changes we according to need, according to power. So it's being it's a continuous project. We get the ideas, we change it or whatsoever. So going on to that, so autonomous robots, obviously cleaning bots, lawn trimming robots, hospitality robots, autonomous drones, and the medical assistant bots. So in any hotel or airports, you'll see these hospitality bots. They will provide you with handkerchiefs, they will provide you with the sanitizer. So all these are kind of autonomous robots. They have been programmed with a special function, with a particular function. They can only do that. So there will be a power source. Like we have to design that also. We have to design the work. We have to design the efficiency, and we have to obviously uh, first think of the hurdles, like what will be the stopping point, what can cause it to stop, and we have to pre-program it for overcoming that stoppage. So we'll go through one by one to that. So this was our robot, and a very small robot which will continuously surface over your room and surface over your whatever buses or metros or homes or offices. So it will keep on going on, and it's a rechargeable one. So obviously, whenever the battery is low, it will sound up, and you can charge it again and again. So coming to this, So our center has developed UV flow disinfector robo. We call it robo because obviously this is an autonomous one. This product provides the chemical-free solution to disinfect the floor surfaces of vehicles like buses, metro flights, and hospitals, offices, home to eradicate the bacteria and harmful pathogens. So actually, the concept is using the UV rays. So as you all know, UV rays, there are three types of UV rays, A, B, and C. So we will be using UVC kind of radiations, which can go through the DNA of a particular pathogen and kill it. So, going to the disinfection technology, what kind of technology is this? So, ultraviolet germicidal eradication is a disinfection method that uses short wavelength ultraviolet C light to kill or inactive microorganisms by destroying nucleic acids and disrupting their DNA. So, basic function is to disrupt a DNA. So, after that, it won't be able to grow, it won't be able to disinfect your surface any longer because you have killed the DNA. So that is what this technology is, UVGI. It's used in a variety of applications such as surface, food, air, and water purification. It has been going on for a long time, UVC radiations. So on the UV light spectrum, we know that 100 to 400 nanometers, that is UV ultraviolet radiations. That is the wavelength range of our ultraviolet radiations. So coming to the lower side, that is if we go for like 100 nanometers, higher than the 100 nanometers, the range around 200 to 270 nanometers, that is the particular range when a UV radiation of C type will kill the bacteria, viruses, or anything which is harmful. It will actually go to the DNA and destroy the DNA. So we'll be using the UV LEDs, which will be working at in between this range, 200 to 270 nanometers. That will be the range of disinfection technology of UVC radiation. So UV light obviously is a reliable, well-studied and antimicrobial technology. It works primarily by destroying the DNA inside the bacteria, virus, and the fungi. So you kill the DNA, you kill the virus. UVC light has been used for decades to disinfect industrial surfaces and sanitize the drinking water. Obviously, it has been going on for a long time to actually sanitize and to actually disinfect the surfaces, water, food, etc. So it is especially advantageous for use in hospitals because it kills this poor forming bacteria. So obviously, the bacteria or the virus, they keep on growing. So they'll develop a culture over there. So if you destroy its DNA, it won't grow. So obviously, you'll just get rid of these infectious viruses, bacteria, which are harmful to our skin, which are harmful to our health. So overall scheme was dry disinfection. Dry disinfection because from the past year we all have been using sanitizers, hand sanitizers a lot actually on the surfaces, on our body, on our hands, everywhere. So dry disinfection where we cannot reach with the sanitizers. We obviously cannot go everywhere with the sanitizers. So, sterilization using deep ultraviolet LEDs fitted on a robot is a great solution with a compelling package that brings in ease, speed, and effectiveness because it's oriented to get that with like higher efficiency of getting the speed. So, it has to be easy. It has to be because keeping a normal common man in point of view, he has to get a particular device which is very easy to use, so he doesn't have to worry about what actually I have to do, what actually I have to change, what I have to go through to actually proper functioning of the robot. So we have designed a very simple case. So in which you will just get an adapter, you will get a connector, you'll connect the adapter to it, it will charge itself, and you can go on with the working. So it's not gonna to like go dead or something like that. So it has a power battery source which will keep it on working when it's not charging. Whenever the battery is low, it depends on the battery is like we give it a 11.1 volt. So we have given two parallelly connected 11.1 volt to just increase the operating time. But the motors we have used in this vehicle, they will go up to like 8.5 volt. After that, the robot will slow down. So at 8.5 volt, we have to get the notification. So for that purpose, we have introduced a buzzer, a voltage comparating circuit to this. We'll all discuss these points in the coming slides. So this robo is an automatic mowing vehicle and cost-effective solution, obviously, for the disinfection. This device is fitted with a rechargeable battery equipped with sensors able to move autonomously within a room, avoiding the path obstacles. So you see, we had to go with the in this line we have seen three aspects. Like first is its function. We have to program it to function autonomously. Second is the power source. So we have to get it a rechargeable battery. Third one is the sensors. We have to put sensors in the robot, obviously, so that it can overcome these जो भी रास्ते में जैसे भी जो भी obstacles आते हैं, so we have to avoid them, and we can our robot can move easily. So these will be the different parts we're gonna discuss in detail. So this is the internal structure, what our robot actually looks like. So you can go with the different ways if you have want to make a. It's a simple DIY like Arduino project. It's based on Arduino, so it's a simple Arduino project in which we have used normal DC stepper motors as simple 300 RPM wheels and an ultraviolet ultrasonic sensor. Sorry, ultrasonic sensor, and obviously there will be a power source. The two sources which we're using at the last corner of this vehicle, these are 11.1 battery cells we have introduced as like power backup of this device. And let's see. So structural part, first one, obviously the Arduino controller, so which will be executing the automatic all direction movement of the vehicle with the smart obstacle distance comparison program. So it's not only important to measure the distance, you have to measure the distance and make the decision also, because whenever we have to overcome an obstacle, what we have to do is like you see the distance, you have to make an intelligent decision which way to go now. Like for example, there is like 10 centimeter distance on your left and 20 centimeter distance on your right. So obviously it will compare the left and right distance and go to the right, because the distance is higher than the left. So not only that, what if like there is a wall after 20 centimeters, what will it do then? Now it has already moved to the right, but it still has to overcome that wall. So what will it do? It will go a little backwards and then again start judging to his left and right, and then go on with the process again and again. So that is what an Arduino can program it to do. So that's why an Arduino. Among them, the automatic navigation vehicle is used for carrying the robot to patrol and navigate on the floor surfaces according to the available route. Whatever route the program decides, your controller decides, so it will choose that route and keep on going. So there will be a L29 3D motor shield. Obviously, there will be a motor driver used for this, because Arduino cannot directly give power to those four DC stepper motors. So we have to use a motor driver, because we have to get a bipolar stepper motor. So we have to change the direction. Like if it's going forward, now it has to go backwards. So obviously we have to go through the circuit. So we have used this motor driver, that is L29 3D. Next, ultrasonic sensors that will help it move hassle free in any direction, avoiding the obstacles. So, wherever there's an obstacle, it will compare the distance first, and in case it strikes, for example, due to somehow reason it strikes somewhere. So, what will it do then? So, it will move backwards and then start again comparing. It will move its head to left, then to front, then to right, and it will compare the distance. The programmer will compare the distance and then move the robot accordingly. So UVGC technology, ultraviolet germicidal technology. So we'll be using ultraviolet LEDs. Ultraviolet LEDs. There are different kinds of LEDs, ultraviolet lights available in the market. We have used the smallest one, 3 watt UV LED lights. Rechargeable 11 volt DC power supply to meet the power requirements of the device and also keeping it lightweight. So obviously these cells, they don't weigh much, so we have to get it on a lighter note, so that it can move easily around the surfaces. So we have our work is done in 11 volts, so we have used the minimum 11 volt DC power supply, and we'll keep it on charging until and unless it drains out of the battery. So low battery alarm system that will make sure the device beeps the alarm. So as soon as the battery is discharged, so that the user upon hearing the alarm can change the device, charge the device, obviously. So as I said earlier, we have designed a lower battery alarm system in which we are using L3 LM339 voltage comparator IC. So we have to get our robot stop at like 8.5 volts, because after that there won't be enough power for the wheels to drive like on the normal speed. So the speed will it won't just stop at 8.5 volt. The speed will decrease very rigorously. So obviously, to ease the process, we have designed an alarm system that is at 8.5 volt. So, just a heavy idea of like what actually our structure is. So, we have designed what we have connected to the Arduino board. So, Arduino, and obviously, there will be a motor driver IC to drive all the stepper motors. That is, we have used 4 wheels, so 4 stepper motors, 2 on the left side and 2 on the right side. And then there is the power supply unit, obviously, that is actually 3.7. We have used 3.7 volt cells, 3.7 volt cells in the series, so it will give us 11.1 volt. So and then two 11.1 volt cells in the parallel, so that we can increase the backup. So that is about the power supply. And then among the sensors, we'll use the ultrasonic sensors and the servo motor just to make our sensor see in all directions. Because as I said, we have to look forward, we have to look on the right, we have to look on the left. So there's a servo motor which will help the ultrasonic sensor to do that. And after that, obviously, the UV LEDs, the major part of the robot, which actually does all the functioning, that is UV LEDs, ultraviolet LEDs with the C radiation, UVC radiations, and we'll be working on 220, 223, 250 nanometer radiations, which are actually used to get rid of the DNA of the viruses. So I hope that you all are familiar with the Arduino Uno microcontroller, a basic microcontroller, like which is being used for different electronic process to communicate within the sensors. So this is what we have used, Arduino Uno microcontroller. So we'll be generally using the USB plug for programming our Arduino Uno. So Uno board will be programmed as per the program. We can discuss the program later. So this will be what we'll be using. We won't be using an external or USB power source. We'll be using that external power source only, which we have designed. That is 11.1 volt. Our both motor driver and this microcontroller will be working on the same power. So we'll be using the external power supply board on this. This is what initially we designed. What are the parts? So there will be a chassis. So while designing this robot, what we have to keep in mind that this chassis, this brown chassis or the black chassis you're seeing, you have to decide what actually material you're gonna use, because depending on the wheels, depending on the motors, depending on your speed, you cannot go with the lighter material. You cannot go with the very light material because it will jump. It won't move smoothly. So it has to be a little stiff than a plastic or a cardboard. So in the final result, we went with the metal one. It weighed around like 100 grams or something, not much than that, but you can use any kind of chases as per your speed. If you have a low speed robot, you can go with a lowest for lower speed. It won't jump, or the back part won't jump, because we had like batteries, we had sensors over in the back part, we had drivers in the back part, so our back of the vehicle was starting like jumping while it was getting stopped. So we came up with the heavier chases. So this is the chases for there will be DC stepper motors. So recommended voltage 9 volt DC stepper motors are good enough, and there will be obviously different kinds of wheels available in the market. What we have gone through is the 300 RPM normal wheels available, and there will be, you have to get a power case to assemble your these batteries and all. So all the connecting wires and all, this is how our chassis looks like when we have just connected the motors and just connected the wheels. This is the main chassis, this is the main body of our vehicle. Then comes a motor driver. I hope you're all getting this right. I'm not going too fast. Can anyone please respond?
Yes, ma'am.
Okay, thanks. So this is motor driver shield. This is L293D. So it basically works on edge bridge circuit. If you will know what that is, edge bridge circuit is like it switches the polarity of the voltage applied to a load. So basically, we have to use two stepper motors, which we in both the cases we have to go forward and then suddenly we have to go reverse. And for that, we have to use this edge bridge ICs. So these are two ICs which are in the motor driver L293D. So basically, these will be power, giving the power supply at like 600 milliampere to your stepper motors. So wherever you have to use four stepper motors like on a Arduino, so it's better to go through a driver sheet when you have to control the movement, like the directional movement of your motors. So you'll go with the motor driver IC. So this is the motor driver IC we have used, and there are different scenarios to actually connect your power supply to the motors. So first one, there are three scenarios. So first one is like single DC power supply for both Arduino and motors, like we have used. So in that case, you have to actually go with the jumper. There was a jumper available right over in this driver IC. So you see these blue parts. Let me show you here. Okay, so these are like where you can connect your stepper motors. You see this DC1, DC2, these are like for two stepper motors. So we have to connect our two wheels over there. DC3 and DC4, these are for different set of stepper motors. So we'll connect two more wheels over there. And then there will be the servo terminals. So you can actually connect two servo motors to this driver IC. We have to use one servo motor. So we'll go with either servo M1 or M2. We have two slots available. So depending on your programming, you'll go with either one of those, and there will be ground terminals for the common ground. And there will be like for this situation, like you have to go with a single DC power supply. So in that case, we have to go for the simply plug the DC jack on the Arduino on the 2-pin external power. As I said, we have to go with the external power on the shield. So in this case, your voltage supply should, like in those cases where we have to go with like less than 12 volts, in those cases we can use these kind of setup. Another one is you go with the Arduino when with the USB, and you go with the motors having a different DC power supply. But in our case, we have to go with a moving vehicle, so we cannot go with this. This is actually recommended on our technical level, on the working of a motor, on the working of this Arduino board. So, but in this case, we have to remove the jumper on the shield. There is a jumper for the external power. So we have to remove this and we can go with the different power sources. Another one is two different DC power supplies for Arduino and for motor. So two different DC power supply. Not this is the case where we don't use the USB power. So ours is mainly the first one where we'll be using because it's less than 12 volt. So we'll be going with the single DC power supply for your driver IC and for the Arduino power board. Okay, so this is how your driver IC looks like. So in this, there will be two ICs, two main ICs for this edge bridge circuit, which will power your DC stepper motors, and you'll connect the main supply, your power supply to this. So M1, M2, M3, and M4. So we'll be using two on the left side and two on the right side. So for depending on your voltages, like what it can bring to your robots, like it is 4.5 to 25 volt, we can connect to this these motors on this driver IC. So each channel on the module can deliver up to 600 mA to the DC motor. So up to 600 milliampere it can deliver to your DC motor. So however, the amount of the current supplied to the motor depends on the system's power supply. Obviously, the uh, main dependency is your main power block which you have used. So in our case, it will be 11 volt. So you can also connect two stepper motors to the outer terminal, one stepper motor to motor port your M1, M2 and another for M3, M4. In our case, we'll be using a stepper motor to power on or to the move function in this ultrasonic sensor, because we have to cover the whole area. So fourth point is the ground terminal is also provided if you have to happen like a unipolar stepper motor. There's a common terminal also available. The shield brings out the 16-bit PWM multiple lines to the 3-pin headers, which you can connect to servo motors. Obviously, there will be different stepper motor pins. So in this case, there will be two 3-pin headers for steppers only and for servers, sorry. Now this is what it looks like when you connect your this highlighted portion as your ultrasonic sensor. So when you connect an ultrasonic sensor, there will be 4 pins like VCC, ground, echo, and trigger. So you connect the pins as per your program. So VCC, grounder, okay, and then there will be echo and trigger. What on what basis it works? This ultrasonic, that it will give out a radiation on the speed of light, and if there is an obstacle it will return back. So depending on the speed of returning back, depending on that time, it will calculate the distance at which that obstacle where the light got refracted or reflected. So it will calculate that distance. So in that case you can actually get the distance from that which is an obstacle in our case. So it will try to remove it, it will try to avoid it before it can strike to that obstacle. So this is how what it looks like when you have connected like your ultrasonic sensor. And you can also use RF sensors, but for that, like if you go with the RF sensors, you have to connect multiple RF sensors. You have to go on RF sensor because you cannot easily move them. So you have to go with like on the front, on the sides also. So we actually we actually went with this ultrasonic. It gave us better results. It depends on your program. It depends on your function. It depends on your what actually you're trying to get out of it. This worked fine for us, but otherwise you can also go with the RF sensors also. So use of the ultrasonic sensor. In this module, we are using an ultrasonic sensor at front attached with the servo motor, which enables the sensor to move in different directions, that is left and the right. So in the program, we have to actually give it the angle, so to the left and to the right. So in our case it will move to three angles, like if it has to move right, so it will go at an angle of 40 degree. We have programmed it that way. So 40 degree, 90 degree to the front, and then again 150 degree to go through the left side. So So depending on your angles, depending on your program, you can cover the different angles, you can cover the different areas. So what we use is 40, 90 and 150. So it gave us a clear range of the obstacle, any obstacle within a range of 30 centimeter. And it also obviously depends on you, what kind of range do you want your obstacle to get sensed at. So as per the program written, we'll send out the pulse from the ultrasonic sensor in the forward direction. If the device will move in the forward direction, or else it has to change the direction. So there is a simple program written for that. Like, you compare the distance, you check the distance in the forward direction. So for example, our avoidable distance is like 30 centimeter. So if there is nothing for 30 centimeters, you move your device in the forward direction. But if there is an obstacle within 30 centimeters, it will stop, it will check for left distance, it will check for right distance. Then the program will make it compare both the distances, the left distance and the right distance, and then accordingly it will make a decision. Whichever is higher, it will go to that side. So to change the direction, the ultrasonic sensor will collect the data from the left and the right sides, compare them, and move in the direction in which the collision distance is larger. So wherever the distance is larger, obviously your Arduino will make a decision that you have to go in that particular direction. To send out the pulse from the ultrasonic sensor, uses the speed of sound and the time the pulse it took to return to calculate the distance. So whatever speed sound if it's using, so the time, whatever time it's using to come back to detect an obstacle, it will calculate the distance accordingly. So this is one of the most of the common ways to use an ultrasonic sensor. This is the actual funda we're using for calculating the distance of your obstacles. This is how it will look like in a block diagram, you can say. So how your motors are connected, there will be different motors connected to this side. Obviously we have connected we have shown one motor, there will be two motors. On this right side, on the upper hand, you'll see a servo motor connected to M2. There will be a servo connected to get the movement of your ultrasonic sensor. This servo's head will be connected to the ultrasonic sensor. Then there is the power source. Power source we have connected to the lower terminals. There will be VCC and ground for that. And you can see the ultrasonic sensor. There will be 4 terminals for that: VCC, ground, eco, and trigger. So accordingly, eco and trigger, you connect these to the pins of your Arduino. So as per your program written, you can use any pins. So these are the ultraviolet LEDs. Have anyone seen these kind of LEDs? Has anyone seen these kind of LEDs, ultraviolet LEDs in the market or in any device you have come through? If anyone has seen, can you please respond? Okay, dead silence. So I guess these are ultraviolet LEDs. If you go from ultraviolet LEDs in market, there will be different kind of ultraviolet LEDs, or you can say tube lights available. So generally, you'll see like higher wattage UV lights available in the market, which we are using in disinfection boxes and or in these ROs, purifiers, and etc. These are small ultraviolet LEDs which are which are having an output power of 3 watt only. So the current requirements will be 400 to 500 milliampere per LED we are talking about. So these emit a light at either 265 nanometers. 265 nanometers is like within the range we discussed earlier, that is 200 to 270 nanometers. If you remember, we discussed that that is the particular range where UVC, that is UV radiation with the C category, will destroy the DNA of particular virus or particular bacteria. So in that range, 200 to 270 nanometers, so this particular led will be using, so it will destroy that particular virus at 265 nanometers. So we can obviously use these kind of LEDs for different kind of purification and sanitization or sterilization processes. So current requirements, and in this device we have connected like 4 LEDs. So which can obviously, if you want to increase the intensity, the LEDs can be increased up to number 6. So we were having, as per our calculations, when we calculated a particular intensity of this, there's a particular method to calculate these kind of radiations and these kind of LEDs to test like what exactly time is required for disinfection. So if you want, we can discuss that it, and like how to calculate the time and how to calculate the distance, that how efficient a particular LED will be destroying the DNA, and how much time actually, if you're talking about a moving vehicle, so we have to calculate like for what time it has to stop, for what time it has to work on a particular surface, so that it actually can kill the DNA. So there is a different process of calculations for that. So theoretically, we have done like we have calculated. We have the this wavelength. We can calculate the energy required. So what kind of energy is required? So as per the formula, like energy divided by time, we calculated the time. So the time required for particular LEDs will be like 9 seconds, 9 seconds maximum, this particular LED to kill a particular surface is whatever available is like strengthened on that surface, it will do its work in 9 seconds. So in this case we have used like 3 to 4 LEDs. We can go for like 6 LEDs. So as per the distance, like the exposure of the distance, like our for our particular robot, it is like 20 to 25 centimeters. So 25 centimeters, for like we have to stop it for like a few seconds and it will get the work done. We don't have to wait for 9 seconds because that is for 1 LED. So we are increasing the intensity. We are going for 4 LEDs. So obviously the time reduces. So the voltage requirement 5 to 9 volts, and the current requirements 400 milliampere. And obviously the most important part, whenever you try to buy these kind of LEDs, whenever you go for these kind of LEDs, you have to check for the wavelength. So we'll be working on the 270, what's mentioned, or it's like characteristic, that is 270 to 280 nanometers. That is C type of radiation. You have to go for only C type of radiation, ultraviolet LEDs. So this is what we have used in our project.
Excuse me,
So
madam.
yeah, sure.
Ma'am, what is the distance between the surface? And
Distance,
also,
yeah.
yeah,
Our robot is having like these are like at 10 to 11 centimeters. So it will work from 10 centimeters. It's quite close to the ground. So depending on your calculation, depending on the intensity of your LEDs, you can change the height, you can change the robot design. What we have designed is at like 10 centimeters approximately, at intensity of, and this intensity will be like 2 to 3 seconds, because we are using 4 LEDs. Is that clear?
Excuse me, ma'am.
Yeah.
Ma'am, what sort of calculations did you do when you had come to a conclusion of using 4 LEDs instead of 6?
In that case, you'll be just increasing the intensity. So intensity is directly, like in this case, it's directly proportional to the time. So we are talking about, when we did the calculations, we did it for like per LED, and that was 9 seconds. So if we are going to increase the intensity, and will for that intensity we will be giving the exposure of UV radiations to the particular surface, like at a high intensity. So as per we can discuss the calculations at the end of this presentation,
Okay.
what
How
we
did you
have used.
decide upon the intensity value, ma'am? Then
It's
is there
it's
any specific? a reason for setting the value of intensity while we are deciding upon the number of LEDs to be used?
See, the number of LEDs is like all the LEDs will be having the same intensity, right? So we have
Yes.
connected them in like series.
Okay.
So the area, the particular area, if we connect a particular LED in the center of the vehicle, so
Okay.
obviously the intensity will be less as compared if we have connected like four LEDs. So in that case, the higher intensity of your LED,
Okay.
because the number of LEDs are higher, so the intensity the radiation power of those four LEDs will obviously decide. We have gone with that. Like there was a particular factor on
Okay.
that it will decrease your time.
Okay.
So
What is the
because
maximum intensity value, ma'am?
intensity value as in
No, you have decided upon the number of LEDs based on the intensity, no? So, what is that value of that intensity?
because we have decided the number of LEDs based on our time.
Okay.
Like for particular one LED, as we discussed, like I have to stop for 9 seconds. But obviously, when there is a robot moving, and if you see it's stopping for 9 seconds, so it's a higher time because obviously there will be higher power consumption for that, and the area it has to cover it will be on a very low speed.
Okay.
So we increase the number of LEDs as per that, and that like 4 to 6 is like what our device, what 11 volts can support. So in the four LEDs, we are getting the particular area of 25 centimeters getting done in like 3 seconds or something. So that was our basis of like selecting the LEDs.
Fine, ma'am. Thank you.
So yeah,
Madam, one more question, madam.
yeah, sure.
Madam, did you do any microbiological test on the surface after testing?
This
After
particular
interpreting?
robot, no. We have done testing for a different box we have designed. For this particular robot, we have theoretically done all the calculations and stuff, but we have not got it tested by any lab.
Okay, thank you.
So, power supply unit. Next is what exactly requirements of the device. We'll be providing a DC constant supply of 11.1 volt that I discussed. Like we'll be using 3 cells because we have to keep the power in range. We have to keep in like mind the weight it will be using, and obviously if you know the DC supply more than 9 volt, it's like in a like very heavy batteries available in the market. So we had to go with the small version of that. So we went with 3.7 volt. We have connected three 3.7 volts cells, and that combinedly gave us like an output of 11.1 volt. So we have did what we have done is like two 11.1 volt sets we have used so that we can increase the power backup of the device. So rechargeable lithium ion batteries are used with an external charging point for easy charging of the device. So we have used rechargeable batteries for that. Charging time of the device is in around an air to get a full voltage of 11.1 volt. So we have tested this like full drained battery will take around an hour to go up to the highest value, that is 11.1 volt. So 2 units of 11.1 volt batteries are used in parallel so as to increase the power backup of the device. So because after some time, if you have to like if you use only one unit of this, obviously the device will be lighter, but it will drain much like easier, much early as compared to right now what it is giving us the backup time. Over runtime of the device with the current power until connected is more than an hour. We can obviously go with the higher supply units available, but for that you have to consider the higher weightage it will give to the robot. So our device will work for more than an hour continuously without any external supply, and then you have to charge it again. So if you want to go with the higher range, so you have to use more than 11.1 volt. In that case, you will get a higher backup, higher working time of your device. The maximum voltage output of the battery is around 11.1 volt and will continue to run the motors until the voltage level drops to 8.5 volt. As I discussed earlier, that 8.5 volt is because your motors need that much of energy to keep on working on the same pace. Otherwise, at 8 less, if you go for less than 8.5 volts, your speed of the motors will drastically decrease, and your robot will move in a very low speed as compared to it was moving earlier. So this is what we have designed for low voltage alarm system. So we have used a voltage comparator IC LM339. So for this case, there is a variable resistor connected to the pin number 5. So actually what we are doing is like comparing two voltages. What we have given as input is like 8.5 volt. So we have set our resistor at 8.5 volt. At that time, your register, your LED won't glow, so there won't be any buzzer when it's higher than 8.5 volt. Whenever the voltage will drop less than like 8.5 volt, your buzzer will start alarming, so that you will get a notification that your voltage is now less. You have to charge it. You have to connect it to a charger. So this is our low voltage alarm system. What we have connected on the top, just to get a buzzer. So you'll see like for around an hour it won't start buzzing. After an hour, maybe it will buzz off for continuously. It will buzzer a sound because the user has to know like why is it moving so slow. So in that case we have designed this one system. So we actually did a little bit technical, we checked the speed and all. So after 8.5 volt it was like not bearable. The speed was getting slower, so we like shifted to 8.5. You can obviously change as per your design, as per your wheels. So, the working principle of the low voltage alarm system is the minimum input requirement of the device, that is 8.5 volts. Thus, when the battery reduces from 11 to 8.5, there would be an alarm so that the user can connect the device to recharge the battery. This voltage comparison is attained by the use of LM339. So, we have used a comparator IC, that is LM339. So in this, I see a 5K port we have used, in which like there's a buzzer. So LED one will work whenever there's a high voltage state, that is higher than the 8.5 volt, because the reference voltage is 8.5. So when it's higher than that, it won't sound, and whenever it will go lower than the 8.5 volt, the LED will glow brightly. There will be an LED which will glow, and then the buzzer will emit its sound. So the reference voltage, we will be deciding it by VR1, which you can see at pin number 5. So this will decide your input voltage, your reference voltage. So 8.5, what works for us, you can obviously design your alarm system as per that if you want to design this alarm system. Programming platform for Arduino, we have simply used Arduino IDE software, which is the basic program for to program any of your Arduino board. So it's the program is used for this project is based on the principle to send out a pulse from the ultrasonic sensor in the forward direction. So whatever we'll see in the program, so what our program is based on, that there will be always a pulse which will be sent in the forward direction. So otherwise, if there is no obstacle in the forward direction within 30 centimeters, we have decided 30 centimeters. So it will keep on moving forward only. So after it will take a break. In that duration, when it's stopping, when it's like calculating the distance, we have kept the LEDs on. So they will be doing their own work, and the controller is doing their own work. So if there is no obstacle found, the device will move in forward direction, or else it has to change its direction. To change the direction, now there will be the programming part where it has to actually go with two phrases. Like first phrase is no obstacle, so it will keep forward. Another then is like what if there is an obstacle, so it will collect the data from the left and right side. So there now comes the work of that servo. We have used servo motor. So what will it do? It will change its direction, its angular direction. to like left side and right side. You can obviously decide the angles on your own. So it will compare the distance. It will get a notification, get data from your left side, get a data from your right side, compare them, and then move in the direction in which the collision distance is larger. So the program written will enable the wheels to move in directions like forward, backward, left, and right. Now there are different ways how you program your device. Like we are programmed in a way like it will go forward, uh, and if there is an obstacle, it will first go a little bit like 10 centimeter, 20 centimeter, depending on the program. It will go backwards because that is beneficial in such a way. What if there is a distance? What if there is a like obstacle on your back, on your left side? It was moving in the forward direction, or now it has to go back so that it doesn't collide. So you'll see when you design a vehicle, so you have to go with the hit and run. So like whatever works for your device, so you keep on changing these kind of lines so that it gives you a like hassle free movement of your robot. So after the successful upload of the program into the device, the vehicle should move in all the direction, avoiding all the hazards coming in the way on its own. So whenever you have to just put it down on the surface and it will keep on moving. So what we have done is like we have also mapped it somehow. We connected a we have not used like high technical source in that. We have just connected a marker at the end of this. When we were designing this, we connected a marker at the end of your robot so that wherever it's moving, it will draw a line. So in that way we actually mapped the whole area. We did it like in a 4 by 6 feet area, so it took an around like half an hour to actually cover all the areas. So we searched, we mapped it all along. I can show you in the video how we did it. So let me show you like how it works actually. You can obviously increase the stopping time. You can always alter the angles. You can change its speed. It's all depending like what you have written in your program. We made it go through like rough surfaces also. So The kind of wheels, it will depend, and the movement will depend on the kind of wheels you're using. The earlier one you saw in the images, they were like those one with the yellow plastic ones. They won't work that efficiently, and they will be a little slippery on these kind of surfaces or in the plain surfaces like on tiles and all, so they'll be a little slippery. So we changed the wheels over this part. These are like a kind of rigid ones, so that you don't get that slippery part in your motion. This small brown this brown PCB you're seeing, that is the voltage comparator we have made. And the upper one is the driver IC, and below that will be the Arduino. So if I show you how we did the mapping to actually see whether our device is covering the whole surface or not. So we connected a marker. This is in the trial phase when we're trying it. You have to cover the whole area so that it doesn't go like all around the surface. We covered the area, and then this is how it worked. This is the marking of around 15 minutes or something. And in around 30 minutes, it covered every corner and it covered all the surfaces. I was trying to get this robot to show you today how it actually works, but unfortunately, we have been presented that robot in trade fair. So once you get the things inside, you cannot get them outside till 27th. So sorry for that. That's not available right now to show you because MSME is representing this also in the trade fair. So anyone if is in trade fair, you can go and check out there. So this is what we have done, what we have designed. So as a contactless chemical-free solution to sanitize the floor surfaces, obviously, and the main objective was actually to cover all the surface. So for that, we have done the mapping. So it was actually covering the surfaces. It was going on a repetitive motion. So there can be many advancements to it. Also, you can go with the mapping process with the geolocation tags and all, so that it can actually tell you where it is right now and what it has covered and what is remaining as it does in the Roomba. What they have done is they control it through an app, so the mapping has to be done in that way. So combination of a steady but lightweight vehicle hardware, ultraviolet radiations, smart software solutions through Arduino, which has helped us to design this disinfector robot, which can make our floors virus free in very short duration of time. So the compact and sleek design also, obviously we are just covering, we have designed a cover over this overhead for this one, and there will be only two slots which will be out, that is the sensor, the ultrasonic sensor head, and there will be a particular slot for your adapter. So the connector will be seen so that you can recharge it, and there will be the head which has to move in both the directions. So that is what we have in the presentation for this robot. So I can, if you want, I can discuss this programming. So is that okay? Like
Yes, ma'am.
Yeah, sure. So there will be uh, in initially you have to actually define all your drivers where you have connected it. So the trigger pin and echo pin you see, that is for the ultrasonic sensors. So you have to give them pins. So I not even for that. So you see there is maximum distance. You have to set a distance of what exactly your ultrasonic is gonna go. Like if you don't need a high distance, you don't have to actually send its radiation and use the power source to send the pulses to a very long distance. So we have set it to 300 centimeters. So you have to define the speed of your traction motors, so that that will be 100, because if you go for like more than that, it will obviously drain your power more. So we have set it to 100. And then there will be the offset speed of the true set motors, that will be set at 40. And the collision distance, this is important, where we have to decide where we want to stop. Like what if you want to go to the corners, decrease the distance. If you want to go into the middle area, only increase the distance. So we have set a nominal range of like 30 centimeters. So we can obviously decrease it to 20, 15, whatever you want. So then the define the turn distance, when you have to turn away from that object. So it will always add a 20 centimeter to it. That is why I said, whenever it defines a collision, it has detected a collision, so it will, what will it do, it will go a little back. So that is 20 centimeters, it will go back. And then it will start moving in that direction. So coming these are like how you define your motors and all. You'll define your motors, and then you have to actually get the current distance, left distance, right distance, and your speeds. So what we have done is, when we have written program, what it's first of all, we will go with the servo. Like we have set our eyes on the forward direction, so our servo will be at 90. So if you have, now you have, you'll be changing. You have to check the distance. So what we will do is like current distance and the collision distance. So you'll check whichever is higher. So if it's less than that, so you'll change path, or else you'll keep on moving forward. So this is the funda, this is the basic logic on which your robot is running. So this current distance and collision distance comparison. Now in case of if there is no obstacle, obviously the program is very simple. Like you have to just move your motors forward, stop for some time, move forward, stop for some time, move forward. And when I say stop for some time, that will be defined as per how, at what time do you want the disinfection, how speedy you want your process, like 3 seconds, 4 seconds, 5 seconds. You can put the delay according to that. So now, if there is an obstacle of when you have to change the path, so there comes the program of void of change path. So in that case, you have to first stop, move a little backward, and then you'll check for the distance. Now in that case, what we have done is like my servo right, if you see, that is 40. Now check the distance on the right. So it will your servos will rotate at an angle of 40 degrees. So you'll check your right distance. Then you will check your distance on the forward. It will come back to the forward direction, that is 90. Then it will go to the left, that is 150. Now it will get the data from the 150, that is your left side. So now both the distance, that is left distance and the right distance, it will compare. Now there'll be part where it will compare the distance. Now void compare distance. And what is compare distance? That is if left distance is higher than the right distance, you'll turn left and stop. Or else if the right distance is higher, you'll turn right and then stop. So very simple. Or else if they're like equally obstructive, what if it's like on the both sides, if it's 30 centimeter, 30 centimeters, what will you do then? In that case, you will turn around and stop. So you'll move backwards, you'll turn around and stop, and then again go forward, go check your left distance, right distance. Whenever you give an angular motion to this, obviously there will be always a slightest change in the distances, and it will keep on choosing the higher one, so that until and unless it comes overcomes the hurdle. So that is for the programming part. And then you have to obviously define your forward motion and backward motion. Forward motion is like all the motors, you have to go forward with them, so you have to get a speed offset. Then we'll go with the backward motion. In that case, left motor and right motors, all the motors will go backward. And turn right, you have to define your right motion and your left motion. So in that case, your left motors will go forward and right motors will go reverse. So depending on the simple program, the whole logic is dependent on this, like what you have to do. If you have to change your path, what you have to do for that. And if you don't have to change your path, just keep on moving forward. This is a simple program, this is a simple vehicle program we have written for this, and this is doing well for our robot. If you want to go for like the distance part, if you want to go for like, you don't want to repeat the area, so you have to do geolocation tags for that. You have to get xy location. Like if it was in at your xy location, it won't go back to that location. Obviously it will go to the next location, so you can add that feature to this one. So this is what we have written. And if anyone wants to like ask anything, questions, I can go through that. And otherwise I can show you like what we have, how do you calculate this time. So this is what you asked earlier. So as per the calculations, if I show you like these are dimensions, so total height, width, and all. So the area covered, UV oxygen for an exposure, it has for our device, it is like 20 to 25 centimeters. So around like 2 into 1.4 meters, what we have calculated in different area ranges. So this is our range, what we have calculated for 30 minutes, that is 2 meters into 1.4 meters. That area it has covered in 30 minutes. So 3 watt UVC LEDs, what I already said. So we have used these. You require a voltage for like 3 to 5 volt, 300 to 400 milliampere, and the wavelength obviously 270 to 289 meters. What we have used. So in this calculation will be like what DRDO says, like as per their regulations, it says like for UV radiations 100 millijoules is required per square centimeter. So but at a particular time. So keeping that in mind, we have calculated like what we require and how we are gonna do. So as per the vehicle dimensions, it will be 273 centimeter square. We calculated the area, and then for 1 centimeter square, we require 100 millijoule. So we calculated what will be required for 273. That is what we are covering. So for this area, we have calculated like 27.3 joules. That is what we require. So for this 27.3, we have now the energy rating. That is what is the required thing. That is 27 joules. Then we have the wattage. That is LED power rating. That is LED is like 3 watt. So then we use this calculation, that is what is equal to energy by time. So we calculated the time, that is 27 joules divided by 3, that is approximately 9 seconds. This is going on for like 1 centimeter square, and for what we'll be requiring with one LED, because we have used 3 watt LEDs. So this is with one LED. So that's why I said ki as per you like are increasing the area of the LEDs, you're increasing the number of LEDs, your time will reduce. So depending on that, we are making a stop for like 3 seconds. So if you want to go with like a higher to be on the safer side, you can go for like 4 seconds. You have to just increase the delay part in that forward motion. You increase the delay part, you increase the intensity, you increase the time of effective time of your robot. This is how we have calculated theoretically that how do you calculate like what exactly time is required and what exactly uh, kind of LEDs we are requiring. So 3 watt LEDs are like light, they are easily available. That's what is available easily in the market. And if you go for like higher ones, they are quite heavy and they are all glass made. So obviously you it won't be that like I can say like it will be soft enough like if you touch it somewhere, and if you drop your vehicle on the surface, so the LEDs can break. But these LEDs are like they're very small, they're very fine, they're very it's very rare that you get them broken or something, so they work fine. And for these kind of robotic movements, I guess what was like quite good enough for us, so we did this. So there are always challenges you keep on coming with. So like what if there is like at 9 centimeters, if I say less than 9 centimeters, for like what to do at that time. So you can go for like an RF sensor in that case. So depending on like when you keep on moving with these kind of projects, so you can overcome, like you always see there are challenges depending on your structure, depending on your programming, so you keep on overcoming this. So this is what we have overcome, like with the programming and with the structure. So after like quite few changes we made, so we came up finally with this one. So there is a cover over this, so only the head part will be open, and the charger part will be open. So this is what we created at our COVID time, so to get rid of the COVID viruses. So anyone who's willing to ask questions, please go ahead. We still have time, so we can discuss. If you see like any challenges, you can discuss also that you see any problems with this robot. Please feel free to discuss. We're still in the learning stage.
Madam, what about using FPGA as a alternative for Arduino?
For connecting your power source, or hello?
For programming, FPGA.
Yeah, we can go with that also. Like, but in our case, it was very simple, like on an Arduino based. So it didn't matter much how what kind of platform you use. It was like still using like a very less memory. So depending on your program, it depends like what kind of program what complexity program you're using. So ours was a very simple program, so it was working fine with this. So we didn't go for that. Yeah, obviously you can go with that also. As you see, like the kind of things what you require to add is like the location. That is important. What I see, because you don't, if you don't want that it has to cover the surfaces again and again, you don't have to get a repetitive motion. So in that case, if you want to complex the program, you have to complex the program mostly, and you have to go with the geolocation location. And if I say like as you see, our height is like 10 centimeter from the ground. So in that case, what if there is an obstacle which is like less than 10 centimeters? What let's say there is a 5 centimeter wire going on or something like that. So either you come over that, you come across the wire, so in that case our wheels will overcome it, and you go like above that. But what if it cannot be moved, or it cannot, our wheels cannot overcome it? So what in that case, what I think that like we have to go with a RF sensor. And like if you see the front image of that, so we have to go an RF sensor on the front, that ultrasonic sensor, you'll see a chip over there, so we can go with the RF sensor over there, so that if there is a sensor also in the downward direction, or in the like less than 10 centimeter ahead of us, so in that case we can avoid that also, or change our direction completely until unless there is no obstacle in that way. So we tried it that also in that way also. But in major like 90% of the cases, our vehicle was able to overcome those small substances, so we didn't go for that. but obviously that is an extra thing you can add to your robot. So this is like one challenge, and another one is like if you want to go with the higher working time, obviously if you like want to spend it like few hours, then in that case you have to go with a bigger vehicle, you have to go with a bigger power source, so that you can move it like autonomously for various hours or something. So that is what we felt in that case, but it was getting heavier, so we didn't go for that. So we considered 1 hour, or it was like around more than 1 hour. It was fine enough for our working, so we designed it that way. Or else you can obviously go with the higher voltage power supply, you can connect them. Or obviously you can also increase if you increase like the number of LEDs. So what happens if you increase the intensity, what happens if you increase the number of LEDs? So depending on your power source, in our case 6 was maximum. After that your battery was started to get drained very quickly, so obviously they also require a quite amount of power to work on. So to get their full efficiency you have to give them power supply. So in that case obviously 3 to 4 was enough for us, otherwise they were starting getting heated. That is like what I'm discussing is like what challenges you see as you go forward with these kind of projects. So this is a very basic DIY what like we have done, and it worked quite fine. And otherwise motors they start to get heat up if you don't give a proper backup of your power supply. Your motors will not move at a particular speed, so you have to control the speed also. And when you let them move in any particular direction, when you change your angles, you have to control the speed also. And when you say if you are going in the forward direction, so in the forward direction what it will do, like if you abruptly go with the speed, like I don't know if you have noticed in the programming or not, there's a part when you have to control the speed, this one. So what is if it goes directly to to the maximum setting, so what will it do, like it will drain your maximum power from the batteries. So you have to decrease that also, you have to decrease the power drain, otherwise your batteries will be like they'll be drained in a very short period of time. So that is another thing you have to keep in mind. So otherwise in case of sensors, we can say you can go with the RF sensors. That worked fine also. We used three sensors in the front, in the left, and in the right. So the only limitation with the RF sensors was it's working or the time, the effective time. Effective time as compared to ultrasonic sensors, it was a little bit, I can say, a little bit higher. So we didn't go for that. Otherwise, it works fine. If you want to go with, we have seen robots where it is in every direction, on the back, on the sides, on the left rear end, right rear end, so that it doesn't touch any of the surfaces. But still, we have seen the expectations. In fact, the Roomba also gets stuck. In that case, it starts alarming that I'm stuck. So there are challenges, there are overcomes for that, depending on your sensors, depending on your program, and depending on the modifications you do in terms of user interface. In case of user interface, you can simply build up an app and connect. We try to connect it with the Bluetooth module also. So we developed an app for that, but after that we decided let it go anonymously, like we don't want to control its direction, like move left to move right or get unstuck or something. We designed an app for that also, and we connected it with a Bluetooth module firstly. So we based on that, we initially developed it as a Bluetooth robot, but after that we decided that it should be more autonomous, it should work on its own. So in that case we decided that it should act its own as per the program. So that's what, like, that's the development what we have done right now. And then it started getting to exhibitions, and also we haven't worked it on it like for quite while. So in this is what like what we bought, and also it was a very simple project and cost the cost, if I can say, it was less than 2000 or something. So the whole project, because I'm considering all, like there were hit and trials also. So basic, you can say bomb was 2000 or something. So this is what we have developed, and in that case it makes it as a like autonomous robot, because it has a particular function, it has its power supply, it's like you don't have to go and check it again and again. It gives you an notification, it gives you a buzzer for its like power supply when it's requiring charging. So in that case, it's a full unit in its own. It has a particular function, and in any way it has to do its function. Now there are different types, like changes in your program, like we have what pin we have connected to our LEDs at. So if we want, like we don't want the LEDs to be like glowing when our robot is moving, so what to do then at that particular time? You just switch off the power supply on. In that case, you just have to change the line over in your programming. What it will do, it will stop your LEDs. It won't if your LEDs are not directly connected. So it's very simple. Depending on your program, depending what you have written, you can always change, you can always decide the motion, you can always decide its course. So this is what a basic robot car. If you have developed any project like based on Arduino, the car projects, they look like these simple projects only. But just we have added like a sensor to this. We have added a purpose to its movement. The purpose is ultraviolet radiations. So depending on your calculations, depending on the radiations, depending on your ultraviolet LEDs, you can always give it a proper function. And what we have achieved is like sanitizing of the surfaces. So this is what as a part of a robotic project what I have developed. So anything else I can discuss on this, please? If you have any questions, please ask. I'll insist. Okay, if you don't have question, please suggest any suggestions like how to make it better. Obviously there are different minds going on who are listening me. Please suggest what exactly I should add on.
I can suggest one thing, ma'am. Thing is,
Yeah, sure.
you can add some tentacles kind of a thing, so it can extend itself from the body. So because you're using the under part of the robot, so if you have some tentacles like an octopus, no, it can reach a very wide range of area. But your battery should be capable of delivering that power for that LEDs,
Okay.
extra LED.
So what are you suggesting, like camera based or something?
Like an octopus kind of arm, so it can be extended, no, from the body. The light can be extended, so it can cover a wide range of area.
Yeah, obviously, to cover a wide range of area, you have to provide the main focus is not to cover the area. The main focus is to disinfect also, right? So in that case, if you go with the extension, so you have to, what about that area? So will it cover in the disinfection or not? So if it is covering it with disinfection, so you have to go with the higher number of LEDs. And if you go with the higher number of LEDs, you have to get a higher current. So for that, you have to change your power source. So depending on your power source and depending, I guess, on the area of disinfection. So yeah, your idea is great, fine, yeah, but what we had a limitation in that, like we connected it to a camera also. We got the results from camera also, so that it can see and check, but it was not up to that level, because the program was getting more complex, and there was like the power issues, and what if, like, who is there to monitor, your images? If you have to go like for an app based, in that case it's brilliant. But when you're not going on app based, if you're going for like you have to just put your robot in a bus or something. So you just put it there and don't worry for 1 hour. You have no one to check it out, like whether it's moving, what it has covered and not covered. So in that case, we have done the initial mapping. What we have did, like obviously we can get those results if you have like geolocation tags. You have X and Y distances, right? So for measuring those X and Y positions, you can always get a map, you can always get a graph. So in that way, you can go forward, like whether it has covered every aspect or not, whether it will go on a repetitive motion or not. So for that, you have to go with the X and Y. As far as the extension part is concerned, you have to consider whether you want your extensions to cover the disinfection or not. And if you extend your body, will it be like considered as an obstacle if you can change the extension or not? So in that way, I guess yeah, we can increase the complexity and we can change its course as per that. So yeah, fine. uh anything else what I can well, like what you guys can suggest, what I should add? लाइक किसी के दिमाग में ऐसा आया हो कि अरे ये भी करता तो इट वुड हैव बीन ब्रिलियंट. So please feel free to share that. In COVID times, like we developed different projects. So this is one of the project, like what we were doing. So I don't know what you guys were doing in COVID times. So we overcame like with the thought of this, and let's not use sanitizers everywhere, and let's get the use of ultraviolet rays. So you must have seen in flights and hospitals, they're already using the big devices. They are using like high wattage ultraviolet these tube lights kind of thing, like on a trolley based. uh, I saw a trolley based structure, and there were like LEDs, these tube lights, UV LEDs on the all the sides of it. So they were using all the areas where the light can reach, but you have to obviously, these are harmful for your eyes. So you have to wear glasses or you have to get out of the room. So in that case, obviously you need autonomous thing. You cannot continuously stare in these kind of radiations. So it won't be it will be harmful for your eyes. So for that, if you just leave the robot in the room, that is a great way, because you don't have to go there. It's not a vacuum cleaner, you cannot just move it all along the way. You have to close the room, you let it do its function, you then go and switch it off. It won't matter for a few, like for a small fraction of time, but for a longer run, you should not stare into the UV radiation. So in that case, the autonomous thing has to be brilliant. The obstacle avoidance has to be brilliant, so that it doesn't stop in any case. Like it detects something, it changes its path. Simple. Because on the long run, if you have like put it in a room for like hour or something, it will cover the corners, it will cover all the area. Depending on the distance, depending on the collision distance, you can obviously change, or like if you have the ability to do that, you can change it's whether you want to go very near to the corners, whether you just don't want it in the corners. I can go under the tables and all. So the height, yeah. So less than 10 centimeters only is an issue, and but I guess 10 centimeter is very less. So when you keep the robot on the surface, so if you want to go lower than that, in that case you have to modify the body so that you can give your wheels a height, but the chases will be very downsides. So we have used it on the top head of the ultrasonic. We have put the ultrasonic on the top head. We can obviously, you see, if we lower the height of this ultrasonic, if we use a double chasis system, like if we put it in the downside, so we can obviously overcome with that also. We can increase the this radiation sorry, this distance thing. We can overcome this 10 centimeter distance thing. We can obviously lower it down to 5 centimeter, and which is very far enough, very good enough for like removing or detecting these obstacles. I guess if we put this ultrasonic sensor, this will overcome that particular challenge. But ours was working fine. Our wheels were strong enough, and we didn't see that kind of thing laying down on the surface, anything. So it was working fine for us. But otherwise, you can always like just move it near closer to the surface so that your sensor detects it in a very good way, or gets avoids all that obstacle. So that is my point of view in that. So obviously you guys can have like different ideas for that, or you can go with RF sensor down that. Then you have to just complex your program a little bit. Then you have to go with the RF sensors reading also, that check both the readings, like ultrasonics reading also, and the RF which you have connected to the ground side. You have to get that reading also. Then in every movement phase, you have to compare, you have to check actually if the RF distance, there is an obstacle in the lower part also or not. So if you don't want to go with that, you can just lower your height, lower the height of your sensor. It will work fine. So it works in a way like uh, the pulses are not very straight, so it covers all the area almost. So 5 centimeter is very good enough to get the obstacles, to detect the obstacles. So that's it. That's from my side. What else? I'm just discussing what kind of challenges, because when you start a project, when you come with a thought, and you have to just keep on working on it so that one day it works fine, but you still never get the satisfaction. So you just keep on changing these kind of things. So depending on the like whatever obstacles we were getting, so we changed this. And yeah, you have to keep in mind this also, these LEDs power requirement, because they get heated up very easily if you don't give it a proper power supply. So we have to check that also. This is optional, like if you want to keep it or not, like. But in our case, the 8.5 was pretty enough. Like we didn't want a customer to, or we didn't want our device to get like very slow. So we had to decide whether we want to charge it right now, or keep it going on like for that until the battery fully drains. You see, when the battery fully drains for less than 8.5 at particular time, it will stop obviously, but it will take more time to recharge it to 100%. So 8.5 is good enough. 8.5 was the point where we decided, no, now our battery reach again, get recharged. So this is what we designed. So VR1 is the like the basic point where you can check your reference voltage. You check it to 8.5, and there you go. Whenever it's less than 8.5, it will alarm. If it's not more than 8.5, it will never alarm. So that way you keep that in check. So that's it, I guess. uh, that's all I can think of right now, what I can discuss about this robot. I hope you found this useful in any manner, and thank you for your suggestions. Any question you want to ask, anything what I can share with you. These are, if I say with the programming is very basic of any Arduino robot works on the same principle. So it's almost the same. You can get it anywhere. Only the modifications I have done is the servo, and like uh, to compare the distance, to check the distance. So it's a very basic program. You don't have to change much on that. Depending on your logic, what you want your robot to do, you have to just change the number. So the program is very simple enough. You can get it from anywhere, or if you want, we can share that also. But it's very simple, basic robot program. you'll get it anywhere. Or if you know how to write it, it's very simple. The calculations I've shown you, like these are the calculations what I have gathered the information from the DRDO websites, and accordingly I have calculated like what my robot can work on and what exactly it requires, what time it requires. This is the calculation part, so you can like get this. So I guess that's it from my side. So I've like completed it early. So in because you're not getting any like questions, I'm not getting any questions from your side. So is there anything I can help you else with? Like anything about this robot?
Madam, there's one. There's a website. I don't know if it's there and available in India.
Mm-hmm.
It's called Biophotonics. So I think you might heard about it. So
Sorry,
if
which
you
one?
want to do it, pardon me,
I
Bio
didn't get that.
Biophotonics. It's a
Yeah.
website.
Uh-huh.
So all the people who are dealing with light and
Mm-hmm.
medical devices, no,
Yeah.
the manufacturers, they will be in that biophotonics. So if you
Okay.
can go and check them, and you can find latest technologies in
Mm-hmm.
this kind of photo bacteria killing kind of a
Yeah.
thing.
Yeah. Okay. Fine.
See that.
Thank you. Sure. I'll check that. So,
I have already checked it. It's showing photonics.com. Is it the same website? Sir?
Yeah. It's the same website, photonic.com.
mm-hmm.
They have another magazine called as Biophotonics. So you can check that
Biophotonics.
one.
Okay. Okay. Sure.
It's,
But
I'll
then
check
it's
when
a
that.
I'm
free subscription.
opening this website, it's giving some error codes. Is it open in?
Yeah, yeah. I just checked that one, but it's not opening.
Okay.
I don't know. I don't know. Something happened today, I think so.
Right, maybe.
But I'm getting regular emails from them, so you can just check biophotonics and photonics.com. So you can just check that one. It'll be very.
Yes. Thank you for the information, sir.
Thank you, sir. Thank you. I'll surely check that. Thank you very much. So I guess that'll be all for this session, and you'll continue rest of your sessions
It will be at
afterwards.
12:15. We will start the next session. So
Okay.
thank you, Alka, and
Thank
we
you,
will
sir. Thank you
continue
very
the
much.
session after the
Thank you,
break.
guys. Thank you, everyone.
different types of automation applications that industrial and cutting.
Good afternoon. Now we have joined after the break, that is first session we have completed. Now we are into the session for industrial robots. We have another robot with us. First, I am handing over the session to Dinesh Chandra, Mr. Dinesh Chandra.
Yeah, thank you, Nayan. Okay, good afternoon to all. In this session, we will cover industrial robot. Start with basically we have a Mitsubishi robot. So before going robot teaching process, communication setup, parameters, different types of joint, teaching process, and application. So I'll play one small video for the just little bit awareness what type of job robot can do in our industries and familiarization with the robotics. So just I am playing a one video.
The industrial robot. It's a robot system used for manufacturing. Industrial robots are automated, programmable, and capable of movement on 3 or more axes. There are many different types of automation applications that industrial robots are equipped to handle. Often, robots are designed or integrated with a specific task in mind and tailored to meet the unique needs of that task. Some common forms of industrial robotic automation include welding, material handling and packaging, pick and place, dispensing, and cutting. Robotics are being used in many aspects of manufacturing to help increase productivity and efficiency while lowering production costs. Similar to the healthcare industry, many robots in manufacturing collaborate with workers to perform repetitive, monotonous, or intricate tasks under the worker's guidance and control. With these machines, precision is valued more than speed, as is the ability to be reprogrammed for specific tasks of different sizes and complexities. Robotic manufacturing technology is also becoming safer to operate. Cameras, sensors, and automatic shutoff capabilities enable robots to sense and stay clear of humans in the workplace. The robot's actions are directed by a combination of programming software and controls. Their automated functionality allows them to operate around the clock and on weekends, as well as with hazardous materials and in challenging environments, freeing personnel to perform other tasks. Robotic technology also increases productivity and profitability while eliminating labor-intensive activities that might cause physical strain or potential injury to workers. Despite high initial costs, industrial robots typically deliver great return on investment, or ROI. The productivity gains from efficiency, consistency, and reduced operating costs add up quickly. Part of what has made industrial robots so popular among manufacturers over the past decade. Stay tuned to Galco TV for more tech tips. And
Okay. I think you have observed so many moments of robot which we are using in our industries and different types of application. Now I'll go in a next step. Basically the industrial robot, before going any work to do through the robot, we required a programming, how to program robot for a particular application. So we required a setup, communication setup also with robot, some parameter settings and different types of joints knowledge, and what is the teaching process. Basically, if you want to reach any position through robot, so you require a teaching position, and upload and download program using RT tools. It is a dedicated software for the Mitsubishi industrial robot, and different application we will show. We have some application in house, so we will show the in-house application also. So just I'll move on the RT tool software. I'm going to open RT tool software. This is a licensed version software. It is not a freeware. So in this session, I'll cover how to make, how to communicate with the robot. So this is the software front page. If you see the left corner, it is showing new, open. New means you can create a new project. Open means you can open your existing project on this portal software. If you see this slide, it is showing the new workplace. It is showing the path where your project will save and what is the workspace name. For example, I'll take a example T1, training 1. Push OK. It is showing here step 1, outline. Enter the project name and comment. For example, we will put, for example, a specific application. Pick and place. For example, you want to design this robot for the application as a pick and place. So I am writing here pick and place, and the go to next step. It is showing what type of series of robot you are using or robot. It will be calculated as the end effect. It is the last point of the robot where you are using your tools to pick, or different tools you can pick and place. You can take as a tool, as a writing tool. You can use as a welding gun. Different types of tool you can attach at the end effector. So if you, in our case, we have a series 750D, and we have a type RV vertical 6 axis, and in our case payload, maximum payload is the 7 kg. And what is the model of the robot? So different types of model are available in a Mitsubishi. In our case, it is a RV7FLD. So we will select this one. We will go next step. If you see the step, it is showing here 8-step journey for the setup any robot to do some work. It is a communication setup. So in this, IP address should be matched with your controller. In our case, it is showing 198.168 series. So it is showing the 20. It where you want to connect your PC should be in a same series, and the subnet and mask and default gateway. And the connection method, if you see here, RS232, TCP, USB, GOT. In our case, we are selecting as a TCP. Next step, it is a programming. It is a language designed by the Mitsubishi. So we will not change here. Travel axis. If your any application, you have a different travel axis. I think you have observed in a video, sometime your robot is moving and then doing some work. But most of robot is rigid and mounted in a one place and doing application. If you are moving, then these parameters is required to set. It is a additional axis. If you are more than 6 axis, it is not in your robot, but it is externally. Then you can actuate this one. That time these parameters required to set. Right now, no need to set these parameters. And the same case for the tooling. If you are putting some tools, that time we required a tooling parameters. Next, weight and size of tool. It is also required if you are going to put any tool on the end effector. The finish. This is the process. It is showing message here. Do you want to change operation mode? Means we want to go in a online or in a simulation mode. Basically, this software has a online simulation. We can simulate before without going in a field. We can simulate our robot to connect through this software. So right now I'll go online. So you will see some changes in the left corner workspace. Right now it is showing only offline. When it will connect, it will show online also. So this is the file is ready for you for a program. If you see the online mode, it is showing here program. It is showing one file. Basically, earlier this program, we have put it one file in our robot. So we have a one online file. We can see we have made only very simple steps, only 2 steps. The robot will go position 1, then come back position 1 to position 2, and it will come back to position 1. So just like a dancing between the 2 points, P1 and P2. So how we will set these points, we will cover later on. Before this, we will show some parameters, which parameters is required to program any robots. Are you getting my voice from my side? Hello?
Yes, sir.
Okay. The speed is okay or everything is fine?
Yes, sir.
Okay, thank you. Thank you. Now, if you see the online, so we can see here parameters. Different types of parameters required for the fine application. Means if you see here, I'll show. Basically, better is that I'll show. It is a parameter list. Different types of parameters, movement parameters, program parameters, signal parameters, communication parameters, and field network parameters. If you see in a movement parameters, motion limit means we have a 6 axis. So we required to limit. If you see here, it is showing here joint limit J1, J2, J3, J4, J5, J6. So in our case, we have a 6 axis robot. It is showing the what is the mm and degree. This is the motion limit. So you can decide here your motion limit of the robot also. And also different modes. We have auto mode, we have a jog mode. Jog mode means you are operating your robot through teach pendant. We will show what is the teach pendant. So if you don't want to connect with your software, you can handle your robot through teach pendant also. In jog also you have a different types of parameters you can set from there. And weight, size, tool, user defined area. User defined area, it is showing before going a application. This is the limit for the application we want to our end effector. This is the last limit for the end effector. Or just like you are making a fencing for the robot. This is your working area. Free plane limit, home position. Home position basically it is showing. For example, robot has completed one task. So where it will stay for the next task. Means it is a cycle. I'll say the cycle. Basically, robot will do repetitive job. Not one time it is doing some different task and another time. You can program. You can run different program through the. But if tools is required change, you can change auto mode also. Yeah, in if you see the in a automobile sector, the same robot will do a welding with different gun, but we required a highly automated gun fixtures where you have put it your gun, how to pick different gun. So this is the end effector, the parameterization or different types of spot you can do through the robot. It is also possible, but in a rest time where it will stay for a new job. Okay, this is the home position, very important for the designing any application in a robotics. Collision detection also are very important. When you want to detect the collision, for example, two robots is working in a it is a overlapping between the two areas, or maybe some accident happen, so that time you require a collision detection also. This is the when they will intersect, then you should detect very fast and stop your application process. These are the very important parameters. Warm up operation, this is the time when required you are starting your robot, then this is the warm up cycles. So many parameters. Basically we have a very limited time for the FDP. Basically this is the program we are running here for the 2 months in an industrial robot. So we required a more and more time. So these parameters, that time we are going in a depth. Some program parameters, language also you can set, and the slot table. It is a different for the this application. Right now we are not doing this. And the signal parameters output. This is also the some. It is showing caution for any do. If you are doing in an online mode, so many caution required. If you see cannot find common parameter list of the file format, illegal, please download parameter list from the robot controller using the parameter screen. It is showing. So some message also you can see there. Bus is famous for the Siemens, Divines is famous for the Allen Bradley, Ethernet, Net IP is all are common for the other manufacturer also. CC Link more focus oriented in the Mitsubishi. So this is a good, no problem. Also, we can monitor the field health through this one. I also monitor the robot movement signaling. Signal means handshaking signal. For example, general purpose signal. These are the slots are available in our robot controller. So you can configure different application 0 to 16 bit or 16 to 30 bit. It is has more than 128 signal, digital signal, DI and DO signal you can monitor here. You can connect as your application is required. If I think you have observed in a video, they have shown application based, you can design your robot. What type of application you want to run, then it is you can program it. Also in a online we can see the some maintenance origin data. Origin data is a very important. Before start your robot, you required some origin, means the you have a 6 axis. J1 should be in a origin. It is a by default position. The manufacturer has given us some notch to match this notch, and then you can say this is the your zero origin point. So that time we have a different type of method. Mainly we are using ABS or tool. ABS, it is showing method where you can put your values as per the guideline and set it in a field also. So it is, or you can say it will calibrate the position at it is a origin. I'll take a one example. For example, I want to run 30 mm from my location, but where is my reference point? So you can say the origin just like a reference point for robot. It is a zero position for robot. It can move from this one and then taking feedback from the field. Field means it required a encoder. In encoder, it is showing the positioning and the velocity, these kind of information it is collecting from the field, going to the controller. Controller is taking decision. This is the last position of the my arm or manipulator. Basically, robot, in terms of robot, we will say in two parts. One is manipulator or another is your controller. Controller is controlling the all these things, but manipulator actually doing the physical work. So in this, I think we have covered so many parameters or these things. So let's go in a okay, or I think we will take a backup. How to take backup of program and controller type, robot type, it is automatically fetching from the controller. You have connected online, it is fetching automatically. But backup information, what type of backup you want means all files, program files, parameter files, system files. These are the files also we required. It is showing also backup path where it is saving the your project, or it is showing here. If you see the my mouse rotation, it is showing here robot controller, or it is showing here your as a PC, or it is showing arrow, means controller to PC program is coming. If you press here, so it will show information among the robot controller is written in a specified folder. Already we have backup path. So yes, so it is taking a backup. It will take some time. It depends on the how much the program inside. So now it is showing here Melfa RT toolbox backup RC to PC, and your controller to your PC has been completed. So we can see here our program. Simply it will show here. So we have written only 2 lines because in this training session, if we will write a lengthy program, very difficult to describe in this particular time limit. So that's why we have put it only 2 lines. Okay. So before going programming mode, I want to show where our robot physically mounted, or I'll show our lab on this application. Okay, so wait a moment. I think we can connect that one. This one. Yes. Okay.
So we will show our just you can pull out. हाँ तो just हाँ no problem. So I'll show this. This is our basically lab. Yeah. This is the fencing for the basically whenever you are going to install any robot, this is the fencing. This is the door. It should be closed always, always and always. Yeah, better. It is visual. Hello.
Yes, sir.
Yeah. So this is the inside. Robot is inside. Okay. This is the fencing for the robot. So whenever you are putting your robot for the any dedicated application, so required a fencing for this. In this case, we have made a partition, or this is the door. I am opening this door. Also, we have put it here. If you see, we have put it here a one limit switch. If it is not pressed, the robot will not work. So it is working as a emergency, right? If you are opening in manual mode, we can run our robot. If you see, this is the controlling unit for the field devices. We have a different application here. It is a conveyor system where we are using a pick and place things. You can, I think so, you can see here. It is visualized. I'll go down also.
Yes, sir.
Right? If you see here, just come, Mike. I'll show here, I'll show some things. No? So these are the sensors. If you see here, these are the sensor, belt, screw type of motor. We have mounted motor here also. So this is the one application. If you see, this is the bed where we are putting a product through this robot. This is our robot. This is our robot. So we will move. We will show here. Come. So this is the conveyor system. The product we can put here also. It will come up. Left will come up, and will product will move from this location to this location. We have a barcode analyzer also sensor. It will detect it. If barcode is put it on the product, it will transfer in our next conveyor. Otherwise, it will show the alarm. This is the robot, Mitsubishi robot. In robot, we have a different joints. I think we can come close. It is a visualize J1. Hello.
Yes, sir.
It is visualized now. And if this is J2, it is visualized.
Yes, sir.
Right. J1, J2, these are the two joints. Different. We will show. This is another one. And when we will teach our robot, so we will show one mark here. If you see, it is given by the manufacturer. We have a one mark in the downside, another mark is the upper side. So whenever we require the zero position of a robot, it should be matched, and that time we will teach our position. This is the zero position. That means we are ensuring this is the zero position for the robot. Then after that we can program our robot. This is the end effector. This is the last one. This is your tool. In this case, we are using suction cup. This is the suction cup. In our application, we have a different types of blocks. So we can pick this product from this location, and it will move in a different shorting location, and we can stack in this position also, right? So I think right now enough information regarding the robot. Then we will go to our teaching process or some parameterization, right? Or also we will run a one program, a small program on this. Okay. So I'll go in a RT tool once again. So I have shown some joints, not a whole, but it has J1, J2, J3, J4, J5 and J6. If you see in this program, we have written only two lines. Okay, before going in a auto mode, we will move our robot through our teach pendant. So better is that I'll show some teach pendant function first. So how we are rotating our robot manually. So I'll connect once again to our video. Okay. Pendant तो इस पे ज़्यादा angle. So this is the another device we can control our robot, and when you are running your robot in a auto mode, so it will not work. So we have a different types of mode of operation. So right now I am just showing here how we can use our teach pendant to setting up our zero position, and also showing the reach, different type of things we will see here. If you see this robot, we have a different keypad. It is showing here. If you see -x +x means J1, J minus rotation plus rotation, J2 minus rotation plus rotation. Same thing for the J3, J5, J6, it is showing here. Also has some function here, speed and the servo on, monitor, jog. These are the different function you can control through this teach pendant. Also a very interesting thing, you can't move your robot. This is the lever. If it is not pressed, you cannot operate your robot through these keys. Also, they have provided one emergency. If anything going wrong, you can press immediately. If you see, I think you are getting some beep. Hello?
Yes, sir.
So it is showing some measure is in field. So please check your field. They have given a reset button also. If you press this reset button, your alarm will go. Or if you, I'll press once again. Also, I'll show one thing. If you see, it is showing clearly error with error code. So you can easily identify what is going wrong with robot, or what is the root cause for the robot to resolve this issue. So you can consult your robotic manual, so you can see and remedy for the resolve this problem. In this case, we know what is the problem, so we are going simply reset. It is resetting, it will disappear from the your screen, right? So I think we will move one by one. Just so just before going the manual operation, your robot should be in a manual mode. So we have a one selector switch. Can you show there the selector switch? एक वायर है पैर पे आपके, जल्दी उठना है ये, this is the वो वाला last, right? This is the auto and manual mode. This type of combination we require. So right now we have put it our robot in a manual mode. Now, आराम से come back. We have a one more key here. If you see, I think you can see the light is on, off. Anybody? I think it is visualized. Light is going on, off.
Yes, sir.
Hello. Yeah. So it should be pressed. Okay. That's mean you required if you want to move your robot through this pendant, it should be pressed. Also, this lever should be pressed like that. Okay. Then you can enable your robot. Otherwise, your robot will not move. Okay. So I am pressing. So I have pressed this one. No problem. Okay. I am operating like that. Basically, your hand should be like that. Okay. In back side, I am pressing. Right. If you see here, one thing is a more servo. Servo should be on. Means we have a 6 servo motors in a 6 axis. Servo should be on. I have pressed. You got some click type of sound.
Yes, sir.
Yeah. Off. Just on. Once again. Okay. Right, sir?
Yes, sir.
Yeah. We required some feedback from your side. Basically, if you are giving an answer, then I am motivated here. Then no problem for me. Okay. In this T pendant, we have a one jog. Means manual operation through jog. So I'll press this one. It is showing here what type of work you want to do from this T pendant. Okay. Jog. I have pressed here jog. You want through 1 by 1 joint, or you want to XY, means 3 mode, it will calculate automatically whenever you are pressing your keys. Okay. Is a safer side is always move your robot in a joint. So select this one. It is showing here joint. So I'll press joint. So it is showing here, it is visualized J1, J2 position, these types of it is visualized for you. Hello.
Not very clear, sir.
Okay, it is not focusing. Just wait for a moment. We will try.
But we'll take a word, sir. It's okay.
Okay. Now?
Yes, sir. Yes, sir.
Yeah. So it is showing your current position of your robot. Okay. Means J1 position, J2 position, that kind of thing it is showing. So just can you note down the J1 position? Just I am giving an example for you. Basically, I'll move and then I'll show once again. I think position is the 11.57.
Okay, sir.
11.57. Okay.
Okay, sir.
Okay. So just, yes, come closer. Also show the position. This is my J1. If you see here, right? So just I am pressing this one. If you see here, robot is moving. ऊपर देखो. Robot is moving in a one direction plus robot is moving in a another direction. ये joints. Show this joint. It is moving.
Yes, sir.
So manually you can rotate your robot also, right? If you see in a hole, it is coming this direction. I am pressing minus. It is going in a reverse direction, right?
Yes, sir.
Now I'll show the J1 position once again. It is visualized for you. Mobile, we can use mobile. Just we will try with mobile also. So same thing I will do with the J2. It is going up and down. It is visualized.
Yes, sir.
The same. I am doing this one through this one. Our T is pendant. Okay. J3. It is showing. Hello. Yeah, I think so. This is visualized.
So minus 3.7, sir.
Right. So we have noted as a 11.57.
Yes, sir.
Yeah, so that's in position is changing. So just I have pressed. If you see right now,
Minus 15.
yeah, so that's when we can rotate this one. Basically, we are very far from you. Yeah. This training is required offline course. We are trying to show each and everything through the net. So very tough to sometimes tough to understand, but it is good. We are showing in this training. Okay, now so we will move all joints and then I'll calibrate all joints. Okay, just I am showing fourth position. It is rotating. Robot आना चाहिए. It is rotating. Fourth
Yes, sir.
joint. Fifth. It is moving.
Yes,
And
sir.
sixth. It is a end effector location.
Yes, sir.
Okay, so we will do exercise for the calibration. So it required a little bit more time because safety is required. Okay, we are inside the robot fencing. So first we will set our zero position of the J1. Right, sir? I am just moving. I'll show you can reduce your, whenever you are going closer to your calibration point, please reduce your speed If you see in this one, we have a 2 key override. It is showing arrow up, means you are increasing your robot speed. It is showing down, it is you are doing reducing your robot speed. Okay. In this case, whenever you want to match exact through the 2 notch, so you require a lesser speed. So just show the mark. I just connect. Okay. If you see these notch, it is visualized.
Yes, sir.
I think so. It is visualized. 2 notch. One is here. Another is in top. Hello.
Yes, sir.
ये तो फांसना है ना. Visible. Okay. We have another joint J2. J2 के लिए हमें एक मिनट तुम साइड हो थोड़ा सा, पता लगा कि तुम्हारे ऊपर आ रहा था फिर. See this one. We want to match these two arrow. It is visualized.
Yes, sir.
Okay. But we are not getting any response. Responding through. Okay. No problem. Right. ये एक मिनट इसको चेक कर. अच्छा ये यहीं तक आ रहा है क्या? थोड़ा ओपन कर दो. J1, J2, this is our J3. This is the 2 points we have matched. Okay. J4 in the top. It is very tough to show, but we will try. If you see movement, going slowly, no problem. J4 also matched. Okay.
Okay. Okay, sir.
J5. This is our J5. Okay. इसका मार्क क्या होगा? देखो.
ये है सर नीचे. ये है.
If you see this one, perfectly match. It should be perfectly matched. Otherwise, it will be treated as an error. Error means not as a in a running, but as a physically when you want to pick some product from the field and you want to put in another location, it will little bit in a different position. Okay. This is the 6th one. Come. इसका थोड़ा सा टफ रहेगा ना वो. इट इज वेरी इन इनसाइड. Okay. Now we have set it all joints as a manually. Okay. We can push these data through teach pendant. Also, we can push these data from the our RT2. The safer is that go outside and push the data from the your RT2 software. Okay.
ऑटो मोड भी करना है. हाँ, yeah, okay, no problem. Communication failed. It is showing communication failed. Check. हाँ, आ गया. No problem. It is showing. So I think screen is visualized to you.
Yes, sir.
Okay. So before going the zero position of your robot, you required some manual movement in a field, and also the 2 point they have given. Basically, it is given by the manufacturer. Whenever we are going to any servo motor for a coupling with encoder, it is you can say, when you are pushing your motor or encoder as a coupling, that time you required a positioning of the encoder. That time they are designing the zero position of the shaft, you can say. It is a rotation, it is a position 0 to 360 degree encoder. Different types of encoder we are using, but more famous as on date is a absolute encoder, good for the power failure also. In this case, we have also a battery backup. Every robot is required some critical parameter to store every time. So it is required you can say the battery for the retaining the parameters of the robot also. It is the back side of the robot. It will show the alarm also. If your battery is draining, you can set the alarm what time you want to take a alarm as a precaution, and also for the maintenance. So I'll share some maintenance point, and then we will show the new program step in this way, right? So just I'll finish the zero positioning of the robot, no problem. So it is showing different types of methods: origin data input, mechanical stopper. You can release your brake manually through your teach pendant. Okay, tools, ABS. If you click on this, it is showing here J1 as a 0, J2 as a 0, J3 155. It should not be 0. Basically, the joints has a some middle position. It is treated as a 0 position, but as a encoder data, it should be 115. 115 is your 0 position. You can move left and right. As same thing for the J5, it should be in a 90 degree, but treated as a 0 position. They have given a notch there. It should be match. Okay, all other joints should be as a 0. We can easily check in our teach pendant. It is showing the current value of the encoder. It should be matched with your J1, J2, J3, J4, Jn, J6, right? So simply I'll click here as a set. Already we have set it, no need to set, but this is the procedure. It is visualized for you, J1. If you want to calibrate your, for example, only one joint is giving any trouble to you, so you can calibrate only one joint also. So if you are taking only one checkbox, if you see it is going on or off, it is visualized. Hello. Hello.
Yes, sir. Yes, sir.
Yeah. So we can set our all joints independently. Also, we can calibrate our all joints together if you are clicking all these joints in the same time. So this is the maintenance point of view. If no problem in your robot, no need to set. It is basically required whenever you are installing and commissioning your robot. That time required. Otherwise, in a normal day, it is not required. No need to touch the origin data. Only required you programming points. You can teach your programming point. It is not recommended if you are going to any program in a robot, so no need to touch your origin data of the robot. The same thing I am doing here. Basically, it is set by our manufacturer, Mitsubishi engineer. So right now our robot is working fine. So I'll not set, but this is the procedure. If I'll press this one, set as a origin, this one, it is visualized, I think, set origin. Hello.
Yes, sir. Yes, sir.
Yeah. So right now I'll not set because it is working fine. I can set from this one. I have done manual work in my field. I have setted my notch, each and everything. But is the minor 1 mm difference will be there. It will treat it as an error for the final application. It is working fine. That's why I am not pressing set origin. Right?
Yes, sir.
Right, sir. So this is the procedure. Also one very important thing, whenever you want to set your J5 and J6, it should be pressed in the same time. It should be selected in the same time. Individually, you cannot set these two axis joints. I'll say joint, right? This is the mandatory for the set these parameters, right? So I think so. We have also, you can take a backup origin parameter also. User method basically different. It depends on the what type of problem you are facing in your field. The easiest way is ABS and tool, and all are required. For example, mechanical stopper method. If you pressing this one, also it is showing degree of the robot. Okay, so you should press your robot in a notch position, releasing by your brake. Sometime, if you are not holding your robot properly, maybe fall down. This is the big risk for the set origin in a mechanical stopper. So many things. Safer side is ABS method and a tool. Tools also, it is showing same thing. Right, sir? So I think origin data is finished, right? So I'll share some maintenance point of view of, or also for the designing, how to design your robot application. Basically, this is mandatory. I have shown one controller there. One is a robot controller, another more controller for the handshaking. It is a Siemens controller. I have shown our conveyor system. Okay. So in conveyor system, we have put it different types of sensors and actuator. Actuator is our motors, our cylinders, our venturi for the pick and place. These are actuator, and all other things are as a, we have put it also as sometime push buttons also we have connected for an emergency. So all these are connected to our Siemens controller. Siemens controller is sharing data with robot controller through the network cable. If your field devices input is more than capability of robot, so you required in between the handshaking controller. In this time, we have put it a Siemens controller. It is taking all field data to Siemens controller and sharing the data to robot controller through the network cable, right?
Sir, can you share me the Siemens controller serial number,
Yeah,
sir?
yeah. It is a S7 1200 series. I'll show. Just wait for a moment. I'll stop this sharing. Okay. So we will show through the video. Just
I'll go inside. Better is that. Kanpalji, please handle it. No need. Just इसको handle. No problem. I'll show there. This is the PLC servo and robot controller. Okay. Robot controller we have put it down. Right, sir? Hello?
Okay, sir. Okay,
Yeah.
sir.
Yeah, this is the drives for motor. It is the application of the conveyor system. This is our Siemens controller. Right?
Okay, sir.
This is the CPU section, or this is the IO section, or this is the controlling, means communication for the, this is the communication for the robot controller. It is going to robot controller, or this is the all field devices connected to this different types of DIOs we have connected here. Right?
Yes, sir.
Right. Okay, thank you. Entire अभी करते हैं. Wait for a moment. क्योंकि वो फाइनल रहेगा ना हमारे लिए. Yeah. I think it is visualized for you.
Yes, sir.
Yeah. So now you have seen the third party controller. Basically, I have shown us some parameters in our, when we are setting here. If you see the field network parameter, okay, these are the important whenever you want to connect third party any controller to integrate with your Mitsubishi controller. So handshaking is required. Maybe third party is giving data through the Profibus, CC link, Profinet, DeviceNet. These are the communication protocol basically. It depends on the third party controller, what type of data they are pushing as your application, but it can push data through these network or not. Mitsubishi controller only can communicate through these network. Right, sir? Hello?
Yes, sir.
Yeah. So I'll show the program. So we will go in a program, no problem. I think this is okay from my side. You have seen the physical movement of the robot. You have seen the different joints. You have seen the calibration points, how we can move the robot to calibrated point, and how we can calibrate the robot from the RT tool. Got it? These points? Have you any
Yes, sir.
query? You can ask, or then I'll go in the next step otherwise.
Sir, this robot is much faster than the previous robot, no, sir?
Definitely. Basically, this is the industrial grade robot. Okay, it has a payload capacity is 7 kg. 7 kg, it can lift or it can move anywhere as per the, and the previous robot is the 1 kg payload.
Okay, sir. Thank you.
Yeah. In industry, this is the also a very smaller, you can say. I can't say it is a big one. Basically, 7 kg is nothing. If you see the industrial application, they are picking more than tons
or maybe sometime 2 tons, 3 tons. That kind of robot also are available, but it is very few, I think so. But common robot in industry 50, 60 kg or 90 kg, I have operated 130 kg robot payload capacity. In a automobile sector, it is required for the welding gun. Welding gun weight is very high for the spot welding. So you required a more payload capacity robot, right, sir? So right now I'll go for the programming for the 2 points. If anybody has any question till now, anything I have left, or I am not able to give any particular, I'll say the clarity, if required from your side, you can ask right now, no problem. Then I'll go for the next step. Hello, everyone. Hello. Okay, no problem. I'll go in the next step. So we will connect once again. It is showing T1. Better is that key offline. First I'll go offline, then I'll connect once again online. Just it is showing that time some error. Okay. Okay, no problem. Just wait for a moment. Yeah. Okay. So this is our program. So how to write a new program? Basically, in robot Mitsubishi, they have given a set of instruction. Move is the set of instruction going from one location to another location. So I have used only one instruction as a move. Move, it is showing, it is a, whenever you want, for example, I want to write here, move. It will show the all other format for the this instruction. I have simply written here as a MO. It is showing move. If you are clicking here, it will show here. It is a move instruction. Automatically, it will come. And what is the point for this one? P1, P2 we have already taken. That's when we required P3. In whenever you are pressing the P, it will show that it is for the P base or for the positioning coordinate, different types of instruction there. Okay, so right now we are selecting as a position P3. We have put it here P3. So we required a position in a current position also. So we should add here P3. Okay, it is showing, if you see here, it is showing P1 position, it is showing P2 position, or I have put it simply here P3. The P2 and P3 both are same. Is it right or wrong as a programming?
P2, P3 are different, sir.
Should be different. So that's meant we required a teaching, right? Right, sir?
Yes, sir.
Okay. So I'll show before without using teach pendant. We will show one control panel in a RT tool, and we will move our robot through this one. So first we will teach our P1 once again. Basically, it is we have taken as a origin. So we required a P1 point once again. Okay. So I'll open the operation panel. So just like a teach pendant, if you see here, it is look like some buttons, right, sir?
Yes, sir.
Yeah. It is also showing SVO on, means it is showing the before moving robot we required a servo on. It is also showing here, please change the mode of key robot controller into automatic mode. It is clear whenever you are operating your robot through the PC, your robot should be in a automatic mode. So we have a two switches for the select. ये कर लेंगे automatic में डालिए उसको. Put in a automatic. If you see warning, it is showing warning. इसकी जरूरत नहीं पड़ेगी, हम मूव इससे ही करेंगे. कोई नहीं, रख दो, कोई प्रॉब्लम नहीं. P1 को सेट करना है, वो कर लेंगे. TV enable है. If you see this one, it is showing TV enable key is on. If you have remembered, I have pressed one key in a teach pendant where I have shown as a light is glowing on or off. Hello.
Yes, sir. In the back side you have shown. Yes, sir.
Yeah. So it should be off. Okay. I have now deactivate this one. So I'll reset this one. So everything is fine. No alarm. Okay. Now we can start our servo on. We can servo on. It is showing a status from this one. If you see the black circle here or yellow circle here, I'll just press once again for you. It will transfer. That means servo is off. Okay.
Yes, sir.
Yeah. So I am pressing once again, servo on. It will transfer the status from the on to off. Right, sir?
Yes, sir.
If you are selecting the P1 position, okay. For example, this is your right position for the robot. So just get the current position. Means you have phase data from the robot and ensuring this is the P1 point for you. Right? Okay.
Sir, but you said that all first three joints were 0, no, sir. But
Agree.
here some values are there.
Agree. It is 0, but it has also a position. Na? We can assume this is the P1, no problem. So I'll move robot. This is my 0 position for all. No problem. So this is the position. Na? This is, it may be working position. 0 position also a working position. But we have set it 0 position for the controller. This is your reference point. This is the reference point. Reference point also maybe in a sometime it is a working position. We don't know, but we have set it. It is a reference point for you. Right, sir?
Okay, sir.
Okay. Offline. Why it is showing offline? Okay. So now I'll go for P2. Before going P2, I'll move my robot. So I required once again, some error is showing. Wire disturb हो रही है. एक बार वायर चेक करो, उसका वायर डिस्टर्ब हो गया. हाँ सर. हाँ कोई नहीं, एक बार आ गया, अभी देखता हूँ मैं. हाँ इट इज शोइंग. फिर चला गया. रिकनेक्ट नहीं करना है, जस्ट एक बार उसको प्रेस कर दो ऑनलाइन। वो चाहिए ना मुझे, कंट्रोल पैनल नहीं आ रहा था ना। ओके better is that job joints just wait for a moment, 1 minute. Wait for a moment, just one bug is there, just I'll check. Yeah, so if you see, I am just moving the robot, right? हाँ, वो कैमरा ऑन करके दिखा तो, बट यहाँ से ऑफ करना है ना, फर्स्ट स्टॉप शेयरिंग। ओके 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 गुड। So if you see, I am moving the robot. It is visualized for you. Hello. Okay. Hello everyone. Hello. 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 No response. So we will continue. Yeah.
Yes, sir. It is visible, sir. It's visible.
Yeah. So just so I am just rotating a robot, giving a P2 point. Okay. For example, this is the P2 point. So go to just in a get position. Okay. It is different from the P1. Can you compare? Check the parameter X, Y, Z, A, B, C. This is the parameters for the robot. This is different or both are same? Anybody? Please answer. Connect with us. Basically, if you are responding, then we will thinking ki everything is going fine. Otherwise, we are in dark. Hello.
Yes, sir. Sir. Sorry, I have some issues here, so I couldn't respond.
Okay, no problem. So if you compare the P1 and P2, both are different.
Yes, sir.
Once again, I'll change. Just wait for a moment. The robot movement also you are looking. For example, I am giving a P2 this one. I'll just press on the get current position. It is different. P2 earlier X is position was different. Right now it is different. Hello.
Yes, sir. Yes, sir.
So that's mean we are given a different position from P1 to P2. Okay, we have set it. P1 is the X is 410. P2 is a position as a 420. Okay. So if you want
now we are using that
teach
device.
pendant. Yeah,
Yeah,
no,
teach
right.
pendant, yes.
Yeah, better is that basically tough to adjust through this RT tool because I want to show you movement plus parameters plus video. So three things is possible through the teach pendant and RT tool, and also we have connected one more device to visualize robot movement also. So we have taken some R&D.
Okay, sir. Okay, sir.
Right. So just I am going to P3, right, sir?
Okay, sir.
Once I think it will change.
Yes, sir. There are some changes, sir.
Okay. So the same exercise we will do once again from P1. Okay. So then it is easily understandable to you how we are setting the P1 teach point for the robot, right? Okay, let us example. I have taken this is the P1, right, sir?
Yes, sir.
So please note down the 410. I am just take a current position of the robot. I am just pressing it. So 389 is a P1, for example, right, sir?
Yes, sir.
I'll take opportunity to this one. No, for this one. Once again, just I have taken. Okay, for P2, $429 will change, right, sir?
It changed, yes.
And the for another P3, now all are changed. Okay.
Sir, in the teach pendant, you're using J1, J2, J3. All the joints you're doing together.
Right now, I am taking only J1.
Oh, okay, J1, okay.
We can move J1, J2, J3, J4 to J6 for practical sake. It is easy to maintain. Take only one joint.
Sir, my question is P1, P2, P3. Does it mention J1, J2? How can I identify this data is J1?
No. Basically, robot, if you see the controlling of robot, the controller has all datas in X, Y, Z. It is not as a J1, J2, J3 for the calculation. Inside, if robot is giving output, it has a all axis data. If you see X, Y, Z, A, B, C, all are parameters. It is a understanding, it is a P1 position, but it is a physical position for the robot. Okay, I am pressing only J1 right now, for example. But if I'll press J2, J3, J4 and J6 also. It is look like a XYZ and ABC. Right, sir?
Yes, sir. I think the tool
Cartesian.
position.
Yeah, Cartesian XY. Always robot will give out, controller will control robot through the 3 axis. No, basically, if you have a 6 axis robot, that's mean X minus X, Y minus Y, Z plus Z. That's mean you are covering all axes. That's why it is called 6 axis robot.
So this position is the tool position, sir. This
No,
position.
no, this is not a tool position. Basically, if tool position is entirely different, it depends on your application. Okay. For example, you have put it a tool. You know what is the length of the tool, what is the width of the tool. Okay. It is only, for example, we have put it a one suction cup. In this time, we required only and only height of the our suction cup, right? If you
Yes,
have,
sir.
yeah, if you have put it there as a drill machine, so you require a length and width, thickness of the your bit, all parameters.
Yes, sir. Yes, sir.
Okay, so these are for the next level of the programming, you can say. But in this way, in this program, if you are getting a data for the how to control robot, it is a good thing. If you are going in a next level, or if you have a robot, so you can easily understand at least the depth of the robot is that if you know how to move robot from the in a manual mode, how to robot move in a auto mode, or what type of parameter you require to set before going any application. So we have shown so many parameters. All these are important to how to communicate your controller to your PC. This is also a very important. Teach pen operation also a very important. So whenever you have set it, basically robot is doing repetitive work. It required once in your programming. If any requirement, any change in your application, that time you required a change in your program. Otherwise, no need to change anything in your robot. Only physical maintenance is required. Programming,
Sir,
no need to
if,
change.
if at all tomorrow any error comes, no, sir. So we have to each position we have to check. Each position when you check only, we'll be able to understand where is the error is.
Very, very good question. Very good question. Why I am saying that? Basically, the robot programmer, basically manufacturer has given a very good thing. They have given a set of error code. Okay. They have given a remedy for error code. For example, some problem in your encoder. Okay. So no need to check anything. Go first change what is the how to change encoder. After that, which parameter is required to set, they will give in a remedy. Definitely it is required, but as a maintenance, no need to change anything, but they will give a alarm. For example, battery alarm, they will show, change it. That time no need to change any parameter. If you are doing in a same manner, if you are doing, for example, changing the battery process, power should be always on. If you are switching off your robot or you are removing your battery and then putting a fresh battery, your all data will lost. Okay, so that's mean procedure for changing the battery is that power should be always on. It required hardly 5 minutes, 5 to 10 minutes, but in between, no power failure.
Okay, sir.
So these are the things required for the maintaining the robot. Anything else in this one I can discuss, no problem. Anybody has a question? Okay, so just we will show this one. I think that teaching of the P1, P2, P3, the how to teach the robot, you have seen?
Yes, sir.
Okay, so in continuation, this is our only the program we can see, right? Basically, we are in online, so no need to save anything or download anything to controller. We are basically doing each and everything directly in a controller. Basically, it is a showing here. You are doing any change in a online mode. Okay. So we have a two modes, online, offline. You can go in a offline. You can see the same. Earlier we have put it only P1, P2. It is showing P3 also. Right, sir?
Yes, sir.
Okay. So just I'll wait for a moment. I think controller is working. Put in auto mode. So we will speed. We will reduce the speed. Enable. Okay. If you see, it is showing controller which program you want to run. Okay, so we have given as a 24T. So I'll just select it. It is showing here program 24T will run. Okay, sir.
Okay, sir.
Right. So now required a servo on and start, right? It is showing very big alarm for everyone. Robot may move at the max speed in the following operation. Take special care when operating, right? Please prepare TV to stop anything in emergency. That's mean whenever you are going to put your robot in a auto mode, please hold your teach pendant for one time. If it is running okay, no problem, and press emergency immediately. Right, sir?
Okay, sir.
So just I want to check it. I'll reduce. Yeah, if you see here, override. Right, sir?
Yes, sir.
The safer is please reduce the speed. I have given only 10%. Safer side, always remember whenever you are putting any new program for an application, please reduce your robot speed and then start. And also take care of your pendant. If any emergency, press it. Otherwise, robot will hit. Also, uh, uh, don't stand near to robot. Basically, robot is if it is working fine, this is the very beautiful equipment. But if you are near to robot, it will attack you as a big problem. Okay. So safety first, come out from the fencing zone and visualize robot from the distance. Right, sir?
Okay, sir.
So just I am pressing this one. Start. If you see the movement, it is. I think it is visualized for you. See, it is.
Yes, sir. Yes, sir.
It will rotate automatically. Same thing. It is touching P1, P2, P3, going back. Same cycle will do. Same thing is.
Sir, that is only one command, move. No
Yeah,
repeat, loop, nothing like that.
yeah. I think just this is I don't know. This is the right question for you. You are as a electronics guy, or you are a as a technical. You are
Yes, I'm technically I'm educated, sir. Yes, sir.
in which stream?
I'm electronics communication and computer application.
Okay, very good. So that's mean if you see the for loop.
Yes, sir. For loop, yes, sir.
So if you are not giving any end command for the for loop, it will always rotate.
Okay, sir. Okay.
So in this case, I have not given anything. I have given move P1 to P2, P3. It will automatically rotate the program.
Yes, sir. Yes, sir.
So it is a endless programming. So it is visualized to all. It is rotating the robot through our programming. We have programmed it. It is visualized to all. Hello. Man, man, coming. Yeah. If you see here, this is the J1, it is coming this position and going back. Repetitive. It's the same operation is वो सही है नीचे का देखना the same thing it is going P1 P2 P3 P1 P2 P3 ऊपर का ध्यान रखते हैं right sir.
Yes, sir. Yes, sir.
So I think we have covered all these things. If you have any query, so you can ask. Oh no, power has failed. Oh, no problem. Okay, sir.
Okay, sir. Okay, sir.
Yeah.
Sir, one more question, sir.
Right. Please.
For other J2, J3, sorry, other J6, J7, J8 joins. How is that, sir?
Basically, this robot has the J1 to J6. Okay.
Okay, sir.
Right. J7, J8 means you can add additionally. Not in this robot. For example, if you remembered, I have shown one video. Right, sir?
Yes, sir. Yes, sir.
One time, two robots are moving physically or doing some work.
Yes, sir. Yes, sir.
So that's mean it is also treated as an axis. Basically, it is a movement, na?
Yes, sir. Yes, sir.
So it depend on the place. That's why in video also they have mentioned on very good thing. A robot can do anything, but it depend on your application.
Okay, sir. Okay.
Right? So it is a designing part. It is a designing part, or as a robot programming, which I have shared with you. This is the required whenever you are installing and commissioning any robot.
Yes, sir. Yes, sir.
Right?
Sir, any certification for this software, sir?
Basically, the directly certification, I think Mitsubishi, maybe they are giving. In this, we are giving as a certificate, as a programmer, we are giving as a certificate. Certification is little bit different. Certification is entirely different, basically. Certificate you can get from our side also.
Say, for example, Cisco certification, like that I'm asking.
Yeah, the certification, whenever you are calling as a certification, that means they have a particular, I'll say, the board for the certification process. They have set of pattern, or they are giving as a exam as a globally. If you see the Six Sigma, have you heard about the Six Sigma?
Yes, sir. Yes, sir. I'm certified, sir.
Yeah, you are a green belt or you are a black belt?
No, sir. Green belt. Green belt.
Yeah, I am also. So I am also certified by BE, Bureau of Energy Efficiency. Have you heard about the BE?
Yes, sir. Yes, sir. I've heard about it, sir.
Yeah, so I am certified energy manager from that. Or have you heard about the BHABA, Atomic Center for the RSO?
Yes, sir. I've heard about it, sir. Because I was working in GE, sir. So we used to send our
Nucleic
radiation batches.
Radiation. So which material you are using in your nucleic gases?
No, sir. I'm not working in that company now. 10 years ago, I was working. We were doing CT scanners.
Okay, so the certification is required as a RSO, Radiological Safety Officer.
Okay, sir.
Yeah, so I have RSO also. Okay, thank you. Any question from anybody? Hello. Hello.
Sir, how many types of companies are dealing with the industrial robots, sir?
First of all, automotive sector. Automobile sector is the biggest user for this one. As on date, I'll say everywhere. I'll say, Amazon, so many companies, even the robot. This is the I think you have got information in the day. First, we have a different types of robot, augmented robot, or articulated robot, a special type of robot. That kind of information you got, I think, in this program.
Yes, sir, I got that. My question is in industrial kind of suppliers for robots.
Automobile
Like,
is the biggest.
yeah, like Mitsubishi.
Yeah. Manufacturer. You are asking
Manufacturer.
So
Yes,
manufacturer is the Mitsubishi is one, ABB, or your Motoman, or your Fanuc, Kuka. So many. Even Tata also in robotic. Last 3 year or 4 year back, they have started business in industrial robot. Tata also. And
so everybody will have their own middleware and they will do that, sir.
Yeah, definitely. And also the more robotic Motoman is using for the paint shop in automobile sector.
Okay, sir.
Right. Any question from anybody? Hello. Hello. Hello, everyone. Any question? No, sir. Okay. So, I think everybody is waiting for lunch. So that's why you are not answering maybe. So if no question from your side, I hope this session you got information regarding industrial robot. If any query, you can ask anytime. So we have a 2 more days. In between, you can ask regarding industrial robot from my side. Okay, so we can close the session. So we will once again meet on at 3 o'clock, right?
Okay, sir.
Okay, thanks a lot. Thank you very much.
Here at the session number 3 of day 3. So we'll wait for some time. We'll start with Raspberry Pi today. We'll wait for some 5 minutes and then we will start. Okay, so we have seen the session on a project in the morning session, that is on UVC robot. In the afternoon session, we have seen industrial robot. Now we are on the third session. So because the controller of the Edo robot is made with Raspberry Pi, so we will take a branch to Raspberry Pi today. In this session, we will try to see how Raspberry Pi works. So let me first show you one of the boards. I have with me, this is the Raspberry Pi board. So let me just focus on the board. So this is the Raspberry Pi board that I am holding. So it has got ports for connecting the USB ports. So you can connect the different type of devices to this. And then there is this HDMI port, which we mainly use for connecting the monitor. As I said yesterday, the Raspberry Pi itself is a computer. So you don't need to connect anything other than the monitor, keyboard and mouse to the Raspberry Pi. So let me share a screen and then we will go through the presentation. Yesterday we have seen the website of Edo. Let us go to that once again. This is the website. So here you can see Edo robot, and this is the robot we have worked yesterday. We will work on it further. Tomorrow we'll work on it. And then you have seen Edo Cube. And someone had asked, what is Edo Cube? So Edo Cube, I said, it is nothing but the Raspberry. So this is the symbol of the Raspberry Pi, Raspberry. So we are going into the details of the Raspberry now today. So if you open this box, you will see something like this. I'm repeating. If you open this box, you will see something like this. And inside that, there are multiple ports. These are nothing but USB ports. You can connect some kind of a device to it. USB, you can connect USB mouse, keypad, etc. And this is the HDMI port. To this HDMI port, you can connect a monitor. So through which you will be able to see the display. It does not come with a display, so we can connect it to a monitor. Another option you have here is connecting a display on the Raspberry Pi itself. As you can see here, this is a display that I have connected on the Raspberry Pi. The inbuilt display also can be connected. So now let us go through a little bit of theory. A presentation is there, so let's go through that. Raspberry Pi. Raspberry Pi is the most advanced and powerful board available in the market. yes, it is advanced and it is very much powerful. As you have seen, we have built a robot on it. So Raspberry Pi is very advanced and powerful. And it has got built-in Wi-Fi and Bluetooth. So it connects to the internet through Wi-Fi, and it is also fitted with Bluetooth, so you can communicate to it. Most compact, as you can see, this is a full-fledged computer. Even then, it is of the size of a credit card. So it is a very compact board, standalone computer. It itself is a computer, so doesn't require the help of any other computer for functioning. It is a standalone computer. Allows installation of various programming packages. In Raspberry Pi, you may work with Python or any other languages. So name of some of the languages are mentioned here. Using 40 general purpose input output pins and 4 USB ports, you can connect many peripherals and accessories to the Pi. So it has got 40 general purpose input output ports. As you can see in this, there are 2 pins and there are 20 such lines. So in total, you can connect up to 40 pins. These pins can be used for connecting any input or output. For example, in this case, we have connected the display, an external display we have connected. So the Raspberry Pi is communicating with the display using input output ports. So Raspberry Pi also comes in different models. So the model here in this picture you can see is, to the left is Raspberry Pi model A plus, whereas to the right is Raspberry Pi model B. So there are different models of Raspberry Pi according to the requirement. So what are these different models? Let us see. The Raspberry Pi includes Bluetooth and Wi-Fi, making the most compact and standalone computer. This we have already studied. The Raspberry Pi has the following families: Raspberry Pi, Raspberry Pi 2, 0, 3, 4, Pico. Now, these are the different families. Now, here we have Raspberry Pi model B plus. So, this is Raspberry Pi in 3, it is in family 3. Inside that there is B plus, and in family 3 itself there is model A. So as you can, we will see A and B in detail, because we have in our experimental setup we have Raspberry Pi B plus and A plus. The Raspberry Pi 3 model B plus is the latest product in the Raspberry Pi 3 family. It is even more latest than Raspberry Pi A. So you can see in the picture, it has got more number of ports, etc. Boasting of a 64-bit quad-core processor running at 1.4 gigahertz, dual band 2.4 gigahertz and 5 gigahertz wireless LAN, Bluetooth 4.2, Bluetooth low energy, fast Ethernet, and power over Ethernet capacity. or you can also add separate power over Ethernet hat. Now, one slide I have skipped. So because the term hat came, let me go to that slide. This is a hat. Let's not discuss about what kind of hat it is, but this is a hat. What is hat? Hat is if your Raspberry Pi is not sufficient by itself to do some project, then you can add on some boards on top of that Raspberry Pi. For example, our Raspberry Pi, which I have shown, let me turn on the camera once again. This Raspberry Pi does not have a display. So our project is to show some display. Now this Raspberry Pi doesn't have a display on its own. Then what we will do, on the same Raspberry Pi, we will connect some external hat. That is nothing but a hardware attached on top. On top of that Raspberry Pi, we are connecting, plugging in some hardware. So that is called hat. So this is a display hat or LCD hat. So what are the different types of hats that you can connect, that we will see later, but first right now understand Raspberry Pi. So it is capable of power over Ethernet in itself, or you can also attach a separate power over Ethernet hat. The dual band wireless LAN comes with modular compliance certification, allowing the board to be designed into end products with significant reduced wireless LAN compliance testing, improving both cost and time to market. Fine, it comes with some compliance certification, so it is approved. The Raspberry Pi 3 Model B Plus maintains the same mechanical footprint as both the Raspberry Pi 2 Model B and Raspberry Pi 3 Model B. So earlier to this Raspberry Pi 3 model was the Raspberry Pi Model B. So earlier to this Raspberry Pi 3 Model B Plus, there was a Raspberry Pi 3 Model B and Raspberry Pi 2 Model B. The footprint means the shape, etc. was the same. So I'm turning on the camera once again. Now let me explain by taking help of another board. Let's say this is Raspberry Pi A plus model. So the A plus model footprint is somewhat different from the B plus. As you can see, the B model is little bit large compared to the A. So, but then it is saying Raspberry Pi model 3 B plus has the same footprint as Pi 3 model B and Pi 2 model B. That means the shape of the earlier version will also be same. Meaning what? Meaning that if you have a project wherein you have fixed the enclosure, then you need not change the enclosure of that project. It will remain the same. Because of some lacuna, you would have shifted to Raspberry Pi model B plus, Pi 3 model B plus from earlier version, but then your enclosure will remain the same. Then we have Raspberry Pi 3 model A plus. Raspberry Pi 3 model A plus is the latest product in the Raspberry Pi 3 family. Like the Raspberry Pi 3 model B+, it boasts of a 64-bit quad-core processor running at 1.4 gigahertz, dual band 2.4 gigahertz, and 5 gigahertz wireless LAN, Bluetooth 4.2 and Bluetooth low energy. So it supports this kind of bands. The dual band wireless LAN comes with modular compliance certification, allowing the board to be designed into end products with significantly reduced wireless LAN compliance testing, improving both cost and time to market. The Raspberry Pi 3 model A Plus has the same mechanical footprint as the Raspberry Pi 1 model A Plus. So similar to what we have seen earlier. Then we have Raspberry Pi 0, which is not discussed in this slide. Let me show it to you. How does the Raspberry Pi 0 looks like? So this is the Raspberry Pi 0. I'm turning on the camera. This has been placed inside an enclosure. So I'm trying to find a board without the enclosure. So this is in comparison to Raspberry Pi A and in comparison to Raspberry Pi 2. So Raspberry Pi 0 is little bit smaller in form factor. So either I can open it. I've turned off the camera. Yes, here it is. This is the Raspberry Pi 0. This is the Raspberry Pi 0. It's a small as compared to your Raspberry Pi A or Raspberry Pi B. So it is small in size. Fine. Now having understood the Raspberry Pi, now how do we connect it? So I'll have to show you the screen of the Raspberry Pi. So give me a moment. I'll set it up. You require something called VNC Viewer. VNC Viewer is an application. So I hope it is visible. This is the VNC Viewer. It is an application that is installed. I just search it, VNC Viewer. So, and I open the application. So this is the application. So you need to log into the Raspberry Pi. Now, the Raspberry Pi is emitting some kind of the Raspberry Pi is connected to the Wi-Fi. You need to be connecting to the same Wi-Fi where the Raspberry Pi is connected. So let me first check which connection the Raspberry Pi is connected. So what I'm doing on the display, it is a touch display. I am clicking on the VNC. I've got a stick here, joystick. Trying with the previous because the display is not showing me the buttons where I can click. Let me get the keyboard and the mouse. I'm trying to plug in. Now what I'm doing, I am plugging in. So I was trying with hit and trial with all the IP address from the history, but that is not the correct method. So what I will do is, because I am not able to drive the display properly, so I will connect the Raspberry to the monitor, because in the monitor, the computer monitor, I can make as a display for the Raspberry Pi. So instead of that joystick method, I'm going to use connect the keypad and the mouse. And I'm going to, on the display of the computer, I have a button wherein I can shift to the HDMI. So I am shifting to the Raspberry Pi. If the display is not showing me anything, so what I'm going to do is I'm just unplugging the display board from the hat. So you can see I'm unplugging the display. So now if I plug in the monitor, it will show the Raspberry Pi. Yes, one point here is the Raspberry Pi has to be fitted with some operating system. So we have already loaded a memory card. There is a memory card which we have loaded in the Raspberry Pi. You can see here, this is a memory card. In this, we have burned the Raspbian OS, and the Raspberry Pi board doesn't come with the OS by default. So we have made it a bootable OS on this memory card, and we have plugged in. That is done earlier. So if it is not showing the display, I am shifting to another board. Let's hope I get the display. HDMI in I should connect. So let me just check whether I have connected on the HDMI in or not. Display is not appearing in the computer. So I have to check the HDMI cable. HDMI in it is.
Sir, this VNC Connect we can use, sir. VNC Connect.
VNC Connect.
Connect. Yeah.
Is another app.
Yeah, it's another app, sir. Because I just searched for VNC Viewer, and I searched for VNC Viewer and Raspberry Pi, and I got a result of VNC Connect.
Okay. So we have already got results with VNC Viewer. So that is VNC Viewer is not the issue here. I am trying to get the display in the computer monitor. The issue here is when I am switching the HDMI port, there is a HDMI button. These computers also come with HDMI in. So when you connect the Raspberry Pi HDMI to the computer, you have to connect to the in port of the computer. And the computer, we have a button to shift from Windows to Raspberry Pi. So I have shifted from Windows to Raspberry Pi. In that case, I was not getting the display.
Sir, if you are using laptop,
yeah,
Raspberry Pi,
okay,
which is the input, sir? HDMI. HDMI is input.
HDMI in laptop, there won't be any feature to connect HDMI in. Laptop cannot connect as a HDMI in. It can only act as a HDMI, simple HDMI port. Whereas in some PCs, you have HDMI in and HDMI out. So the HDMI in port is the one in the PC that we use to connect Raspberry Pi.
Okay, sir.
Because the Raspberry Pi is giving out display. So we are trying to give the display on the computer. So the computer is going to take it on the input port. So HDMI in is the one where we will connect.
So I should connect a different monitor for this.
So now I am having to switch to HDMI. Just a moment. So it is turning on. Raspberry Pi is turning on. I have plugged in Okay, I'm setting up. I'm having to restart the PC. So just bear with me. So what are the connections you have to do? One is the power supply. It comes with an adapter. Then another one is you have to connect the HDMI cable to the monitor. And the third one is you need to connect keyboard and mouse to the Raspberry Pi. Now, in some Raspberry Pi, there is only one USB port. Then the question may be, how will you connect both keyboard and mouse to the Raspberry Pi? So the answer to that is you can do power on the Raspberry Pi with simple power, and using remote monitoring, you can control the Raspberry Pi. So what is the remote monitoring software? VNC viewer. Okay, so there is some technical glitch. It is the Raspberry Pi board. When I'm connecting to the computer, I'm getting disconnected from your end. So at that time, I'm having to connect from a different PC. I'm trying to set that up. So some hiccup is there. Anyway, we will overcome it. Just till that time, if you have not marked your attendance, kindly mark your attendance, please. I have shared it in the chat. So I am able to connect the Raspberry Pi. So let me just note down the IP address. So it is 192.168.1.87. So from the Raspberry Pi, we have noted down the IP address. It is 192.168.1.87. So that IP address we are going to use in the VNC viewer. So here we will type 192.168.1.87. So just say enter. It is asking, do you want to connect? So we have connected. So now it is asking for username and password. So even for that, let us go to the Raspberry Pi and go to Raspberry Pi. Its preferences, configuration. The username is Pi. So go back.
Excuse me, sir.
Yeah.
Sir, excuse me. You are not sharing the screen. I mean, it's not visible.
Okay. Okay.
Okay. Thank you, sir.
So this is the VNC viewer. On that VNC viewer, we type the IP address and press enter. It is asking the username. Just enter the username, password,
Okay.
and say OK. I have not used it for a long time, so password I have forgotten. Let me try. Okay. Okay. So let me start with the programming the board itself. So I'll share the screen. So So username is pi. Trying to log in. So here we are in the Raspberry Pi. So this is the VNC viewer from where I have got the IP address. So close it. So this is the complete desktop of the Raspberry Pi. So just like Windows, again I'm
Sure,
not
please
sharing.
share the screen.
Again, I have not shared the screen. So this is the VNC viewer. Enter the IP address, type the username and type the password. This is the
Still not shared, sir.
yeah. I'll have to share one window at a time. So fine. Showing it once again. This is the VNC viewer in your computer. Type the IP address of the Raspberry Pi. It is allowing to connect. I've changed the password. So now with that password, I'm able to log in. So this is the desktop of the Raspberry Pi. So it looks like this. So on the right hand side, it is showing time, volume, Wi-Fi, Bluetooth, VNC viewer. This is where I clicked and got the IP address of the for remote monitoring. AnyDesk, another app that is installed. This is the command prompt. And we have the folders option, how to see the different folders. This is a mini button which I have to close. If the main button I will close, I will get disconnected from the Raspberry. And this is the browser. This is the browser. And then this is the menu button. So I wanted to come to this at last. So menu button is where you have plenty of options. One is the programming. For example, in the presentation we have seen you can do programming in it using many languages. So Python, Java, then Node. So Node-RED. So Node-RED is a block programming. You can do programming using some kind of blocks. So then this is programming. Then education, office. It has got its own office, browser, sound and video, graphics, games, accessories, help. You can browse for some projects. It will take you to Raspberry Pi website. Note that the Raspberry Pi Wi-Fi and our Wi-Fi should be the one and the same. So here this and this is the same. We are connected. So that is why we can type the IP address. So here you can get different kinds of projects. So the main website of Raspberry Pi is raspberrypi.org. So this is the website, raspberrypi.com. Okay. This is the main website, Raspberry Pi website. Here you can browse for some tutorial videos and all. You can learn from this what is the latest updates and all. But anyways, so that was about the website. Then we have preferences. This is where I have changed the password. I had gone to Raspberry Pi configuration, change password, and here I entered the new password and got the password changed. The user ID is Pi, login as user Pi. So that is why when we were logging in, this was showing. Run and then log out. Shut down, reboot, log out. These are the introduction to the Raspberry Pi menu button. So now let us do some the Raspberry Pi has got inbuilt some how to connect inbuilt some website have got some inbuilt programs. So how to connect 2.8-inch LCD to Raspberry Pi 3 model B plus. Now it is independent of the model 2 or 3 or B or A, but anyway I have typed. So these are some of the help websites which will help you develop the project. So this is the display that we have added on top. This is the hardware attached on top. So these are the different pins to which the LCD is connected. So now let us do a simple project. So let me show you what are the hardwares that you can connect. So let me minimize it, stop sharing and open the camera. So what are the different hardwares that you can connect? One, I have shown you this LCD. This is the LCD that we have already connected. Then we have the unicorn hat. What is the unicorn hat? Unicorn hat is the multicolored LEDs that you can connect. So now this is one. Then there are Skywriter hat. What is Skywriter hat? Skywriter hat is a touchscreen touch interface. This is a touch interface. Whenever you touch here on the Raspberry Pi, it will detect some signal, and on the serial monitor you can see some kind of a signal. Then we have Explorer hat. Explorer hat is used to connect analog inputs and give outputs. You can also use to drive motors. Like in the morning, you have seen some motor driving cards our expert had shown. So similar to that is this motor Explore P hat. Then we have Enviro P hat. Enviro P hat is very interesting. It can show you some environment parameters like temperature, humidity, moisture, etc. Then we have camera. Then we have the camera module. You can connect camera to the Raspberry Pi. So this is the camera module. It's not focusing. So yeah, this is the camera module. So let us now, out of all these modules, let us go to one module and we'll try to work out the Raspberry Pi with that module, so that there are plenty of modules. There is no end to it. So let's not go to what are the modules. I have given you an introduction of a few. Let's start with the Skywriter hat. Skywriter hat is Unicorn Hat Mini. Let's say Unicorn Hat Mini. So what I will do is I will attach it. So in this we have a few commands that I wanted to show you. Since the display is already connected, so I will first show you how to switch between the monitor of the Raspberry Pi and the display of the Raspberry Pi. Now the display of the Raspberry Pi is showing white blank display. So I will show you a few command lines by using which we will shift from the monitor to the. So I will open command prompt. I'll have to type cd lcd dash show slash. It has gone to submenu lcd show. There I have two commands. One is dot slash lcd dash HDMI to shift to the HDMI port. To the HDMI port, I have connected the monitor. So I am already displaying the monitor. So now I will not use this command. I will say LCD 28 because it is 2.8 inch LCD and says show. Now it is doing the configuration. It is attempting to connect. Yes, now it is gone on to the display. Now you will see there will be a change from, it has shifted to this display. So Now that is why it is not able to connect to the VNC viewer. So now if I want to shift to this from this display, I'll have to do on the 2.8-inch display. Now you can see I am on the 2.8-inch display. So here, if I want to shift to the monitor of the computer, then what I have to do, I have to, since it is connected with keypad and mouse, I am going to the display prompt, and on this display prompt I have clicked on the display prompt. I am typing cd lcd dash show slash. So it has gone to the sub menu, and then press dot slash lcd dash HDMI, because the computer is connected to the HDMI port. Now it is switching. The display is off now. It is showing blank screen and switching to the computer monitor screen. So computer monitor, I have to share the screen. Go to the Raspberry Pi, say enter, and type the password. So it is showing the display. So this is how you switch between the computer monitor and the LCD display. Now, because I wanted to show some other project, this is a unicorn hat mini, and we will do with one more skywriter hat. So let me just do these two projects. So let's connect the skywriter hat first. Skywriter hat, this is a touch screen where whatever you touch on the serial monitor, it will show you the values. So what I will do is turn off the Raspberry Pi, because any connection changes, you should always power it off. So I am shutting down. Now forever it will say attempting to connect, because VNC viewer task is to connect. So forget about it. By now the Raspberry Pi would have powered off. So I'm disconnecting it. So unplugging the power cable for safety purpose, unplugging the display. So I've removed the display. This display I've removed, 2.8-inch. Now I am going to connect this touch screen. This touch screen I'm going to connect to the Raspberry Pi. 1:1. There is port matching. You can see there are 40 pins on the Raspberry Pi and 40 pins on the touch screen. So I'm just plugging it 1:1, so that it sits just on top of the Raspberry Pi. So it is little complicated. You have to press it little bit hard so that it goes inside. So now my touch screen, that is the skywriter hat, is sitting as a hardware attached on top hat on the Raspberry Pi. Now I connect the power cable. The Raspberry Pi is turning on. There is a LED which is blinking, and there is a green LED, which is like in Windows computers you have a hard disk LED. So like this, on this, if it is on, the active LED is going to glow. So it is active LED is blinking. That means the Raspberry Pi is active. So now I want to connect to the Raspberry Pi. So go to the serial number. Serial number may change after power on, but let us try our luck. Yes, it has not changed. So we are able to connect to the Raspberry Pi. So it is maintaining the same IP address as before power on. So now we want to execute this project. So we don't know how to execute. So go to the browser. Go to the browser. Say type Skywriter hat. Skywriter hat. So go to any of the websites. It will give you step-by-step procedure. This is about buying, so we'll skip this website. Trying out Raspberry Pi gesture sensors. Programming, Thorny Python IDE. So in the Raspberry Pi itself, you would have some folders. Let us view the folders. Documents. Documents is showing blank because we have worked with LCD, so it is showing a folder for LCD. So it is going to give all the type of projects for LCD. You can click on it and it will start working. Similarly, we have to build a project for our Skywriter hat. So in this case, setting, we have not put the right keyword. So we will try to put the right keyword. Setting up Skywriter hat. Okay. Quick install. Support code and API library for the Skywriter, Raspberry Pi hat and breakout board. Okay. Quick install. If you are using Skywriter on a Raspberry Pi, you can use our quick installer to get everything set up and configured for you. Just open the LX terminal and type these words. So copy this. This is the terminal. Paste. Do you wish to continue? Skywriter requires I2C communication. So let us check whether I2C is enabled or not in preferences in configuration. Interfaces I2C is disabled. Let us enable it. So say OK. And do you wish to continue? Yes. Even by this terminal it will turn on, but I have shown you how to turn it on. So it is now trying to install. Once again, it has failed. So trying once again. Yes. Okay, it is doing some steps. So let's wait.
Sir, you are not audible, sir.
Yeah.
Okay, thank you, sir.
So since that was giving some error, so APT failed to update indexes. So because of that error, what I have done is I have gone on to the other link. So this link is going to clone the library. So I have tried with that. So as you can see, it did not give me any error. So let me check in the folder whether it has created any folder or not. Any desk documents? No, it has not. Here, has it created anything? No. Generally, it is available in Pi folder like this LCD show. It will create some kind of a folder. Let's try with a different website. Okay, it is not about building the project. Setting up Skywriter hat. GitHub. Set up a Raspberry Pi 2 device equipped with the this is not the steps. I am okay. Let me try with the Unicorn Hat Mini, whether those steps are available or not. If it is not working, you can go to the other hardware. I just have to show you how Raspberry Pi hardwares are made to work. So let me try. Getting started with Unicorn Hat Mini. Okay. So yes, here it gives me the steps. So let me just power off and then disconnect the Skywriter hat. Maybe we'll come back to it later. Now once the green light is off, the blinking has stopped, the power is off. So I can disconnect the cable or remove it from the power adapter and then remove the Skywriter hat. Removing the Skywriter hat is again critical. Both the sides you have to remove in a balanced way, otherwise the pins will get bent. So now I am connecting the Unicorn Hat Mini. Plugging in a balanced fashion so that both the sides it is inserted. So now both the sides is inserted. This is the Unicorn. This is the Unicorn Hat Mini that I have connected. So power on once again. After power on, go to the, it is showing it is not able to connect. So once again, go to the VNC viewer, enter. The IP address would have changed. So that is why, yeah, it has not changed. not changed. Fine. So again, go to the browser, type unicorn hat mini. It is giving me learn.piperoni.com, setting up, getting started with unicorn hat mini. The tutorial will show you how to install the unicorn hat mini library and then walk through its functionality, how to light pixels, control color and brightness, and then finish with an example of how to make it rainbow. So first of all, installing the software. First of all, you need to enable SPI on your Pi. So go to your preferences and Pi configuration, interfaces, SPI should be enabled. So okay, even VNC should be enabled. So here you can see interfaces, VNC is enabled. That is why we are able to do remote browsing. Okay, once done, open a new terminal, click on the icon in the taskbar that looks like a little black box and type the following. You can copy it. This is the new terminal, paste it here and enter. It is going to do some steps. Alternatively, you can also turn on SPI using the interface. Fine, this is done. In the terminal, type the following, pressing enter after each line. So copy, paste. This is done. Then some folder would have been generated. So let's check the folder now for unicorn. Yes, this is the unicorn hat mini folder that got downloaded because of the previous step. Because of this step which we have done, that is this git clone https github unicorn hat mini python, that folder got created. Now it is asking us to go to that folder. So change directory, cd means change directory, to that unicorn hat mini. Either you can open the folder, or you can go by the command. So let's open the folder. You can see here there are a lot of examples. So go to one of the examples, demo.python, right click, Thorny Python IDE is the application through which we can run it, and say run. It is giving us some error. So Genie with a different, this is the run button. Or else you can try with mu. Please select the desired mode and then click OK. Say run, and demo. Stop, run. It's giving some error, no module named unicorn hat mini. It is saying unicorn hat mini python. So there is no module named unicorn hat mini as shown in the code. The code says go to the directory called unicorn hat mini, whereas that does not exist. So this is somewhere there is an error. So let's go by the method discussed in the browser. So CD unicorn hat mini. So go to that. Paste, enter. Now we are inside the directory of that folder. Then we can do install, sudo install. Then we can do an install. It is doing installation, installing Python, installing this for Python 2, installing for Python 3, installing that code for both Python 2 and Python 3. The installer will give you an option to copy our examples to your Pi. We would request you to say yes. So yes, I have typed yes. All done. Then once this is done, it is probably a good idea to reboot your Pi and let the changes propagate. If the installer doesn't prompt you to reboot, you would, if you would like to tidy up the installer files, you can now delete the directory you cloned from GitHub. We don't want. Now, if you would like to give our examples a go, you can do this. So let's do this. Paste. Yes, we are inside the directory. ls means list out the options. So these are the options. Anything you can run. Python, Python 3, because we have installed this directory for Python 3, we can go to demo.py. So you will see, I will turn on the camera. You will see there will be a change as soon as I hit the enter button. See, the LEDs are glowing. This is the demonstration. Yes, this is the demonstration. So this is how you can make Raspberry Pi work. Is there any doubts? Anything you would like to bring out, discuss? Okay. So now there are 4 buttons here. If you press any button, okay, this is not the one for button. There are other programs that is installed. This is a demo. So let's list out the options and then try with another example. So again, we go to this menu, CD, Control C to exit, Control plus C. So we are again in the examples. So we want to list out. So ls. Now button splash. So let's do Python 3 button splash.py. So I press the enter. So now any button you will press, there is a splash from that button. There are 4 buttons. Right? So this is how we work with Raspberry Pi. So now about the program. Now
Excuse me, sir. Sir, you just a few minutes back you said that a different multicolours LED. What is the name of that instrument? Multicolor LED. You use the term. I forgot to note down.
Yes,
Multicolor
multicolor
LED.
LED. Yes, let me explain it to you, madam.
Thank you, sir.
Unicorn.
This LEDs known to us, generally what LEDs are known to us are single colored LEDs. We all know single colored LEDs,
True.
but multicolor LEDs are LEDs which have got RGB, red, green and blue.
Okay.
Let's say the red color can be varied from 0 to 256.
256. Yes.
Green color can be varied from 0 to 256. Blue color can be varied from 0 to 256. But all these three RGB are in the same LED. When I change the values of RGB, then the color of the LED is something else. So let's say 256, 256, 256 will give some color for the LED. Half of 256, 128, 128, 128 value of RGB will give a different color for that LED. That is called multicolored LED.
Okay, sir. Thank you, sir. Thank you.
Yes. So, anything else anyone would like to discuss? Please feel free.
Sir, now nobody is using microchip, sir.
Yesterday, I think you asked about website for purchasing robotic parts.
Yes, sir. Yes, sir.
Yes. Actually, we have to, let's say, to answer that question, and nobody is using microchip. For what purpose you are asking?
No, thing is when I was studying, we were using microchip. So that's what.
No, it's not like that. Your question is actually, I would say, question is something which is not based on application. You have to base on application. Industries are using microchips a lot. If I have yesterday I have shared a link of a website where you can do online learning. In every slide of video of that, there on the last slide they are saying thank you to microchip. That means they are using microchip product or microchip microcontroller in their robot. So this robot is based on Raspberry Pi. It does not mean that microchip is not there in the market. Microchip has got its own place.
Okay, sir. Thank you, sir.
Yeah. It depends on the application. So based on applications, everybody has their own demands. Everybody have got their own market. So this robot, we will not say is very industrial robot, is it not? It is kind of a training kind of a robot. So don't look at Raspberry Pi as very with that it is working on very high tech robot. Maybe in a high tech robot you will go with microchip microcontrollers. So depends on again on application. So this is a full-fledged computer. The Raspberry Pi is a full-fledged computer, but there are certain drawbacks to it. What are the drawbacks with buying this full-fledged computer and not going with a microcontroller? Let's say if the memory in this is limited, if your project size increases beyond certain limit, then you may not do with Raspberry Pi. Because why? The RAM or the EEPROM or the flash in this is limited. In that case, if you go for a microcontroller or a microprocessor, With the microprocessor, you can buy connect external memory. So if your project is big, requiring lot of memory, then you may go with some kind of a microcontrollers. Even we teach microchip microcontrollers here. So it depends actually on the application. You cannot compare all of them in one platform. So tomorrow we will have a session on expert session in the morning from 10 a.m. Then we will go ahead with other sessions, technical sessions. Maybe we will do the robot teaching method. In this, we will do some programming. So,
Sir, what is your good name, sir?
Nayan Jyoti, madam.
Okay.
I am typing in the chat box.
Sir, because in feedback form that that have to be filled by us later on, I think we have to write down all the lecturers' name. Hannah?
Yes,
As well?
you will get, yes,
And okay,
you will
then
get.
and then what was the name of morning session? The ma'am that took. What was her name? Can you send this all
Yeah.
the
Are you
sessions
able to
that?
see the chat link, madam? I
Okay.
have
Yes.
typed the
Yes.
names.
Yes. Yes. Yes.
And the industrial robot person was
Uh-huh. Nayan Jyoti Tamukna.
Dinesh Chandra. I am Nayan Jyoti Talukdar. Morning session was taken by Alka Bhatt.
Alka Bhatt.
And in the afternoon, you had session by Mr. Dinesh Chandra.
Yes. Thank you, sir.
Thank you, madam. So, anything else? Some glitches were there, but it is just about working with them. Don't worry much about those. It will all be overcome. So, we'll close the session today then. Thank you.